Hey, welcome. This is the vBrownBag build day live here from Ravello. So finally the day has arrived for the Ravello build day. Joining me, well, I'm Alistair Cook for those who've not familiar with my moustache. Joining me today from Ravello is Gal Moav. Thank you for joining us, and can you tell the lovely folks at home a little bit about yourself and your role here at Ravello?
Yeah. So I'm Gal. I'm leading the inbound product management for Oracle Ravello, part of the Ravello team since the early days, 6 years ago, and happy to have you guys here in the Oracle Ravello offices. And
for those of you who are not familiar, the Oracle Ravello is an Israeli origin company. We are not actually at 9 o'clock in the morning on Thursday. It's actually 7 o'clock at night here because we're in Tel Aviv. And Jeffrey and I have been spending an awesome few days here in Tel Aviv. And speaking of Jeffrey, as always behind the cameras, behind the switching, is Mr. Jeffrey Powers, our international man of mastery. Say hello to the nice people, Jeffrey.
Hello to the nice people. Jeffrey Powers here, of course, my Twitter handle being Geekazine. You can find, welcome to the build day, welcome Tel Aviv, Israel. It's 7 o'clock at night, or really early for you in the morning, 9 a.m. Pacific time. So we're going to have a great few hours here building systems, as always. So remember the hashtags, build day live, and of course Ravello Systems is their Twitter handle. And go over to builddaylive.com.
Thanks, Jeffrey. Now, we should preface a little bit about what Ravello, Oracle Ravello product is, that it's part of the Oracle Cloud Initiative, and then the new Oracle Cloud Initiative. They're very different to the older generation of Oracle's cloud. And can you give us the 30-second, this is what Ravello is, introduction, Gal?
Yeah. So Ravello is a service, a cloud service, as you mentioned, part of the Oracle Cloud Infrastructure Services, which include many cloud services in it. And in a nutshell, what Ravello is designed to do is to let you take your on-prem workloads, which is usually VMware-based, but could be also KVM, and just create an exact copy of the workload in a public cloud. And exact copy means the same virtual machines, really the same disks, the same configuration, just copy paste on an exact replica of the network. So same layer 2, layer 3 topology, same features available, VLANs or what have you there. You can take your virtual appliances as well into the cloud, such that so you have your production environment in VMware, you can just copy paste it, run it in the cloud, and do all kind of great things with it. With
all of the sort of mobility and flexibility and pay-per-use elements of public cloud. Yeah. But without the redevelop the whole application from the ground up in order to get it onto public cloud.
Yeah. So simplicity was one of our main design goals from day one. We knew that the process has to be really simple, otherwise there's no
all of those barriers will stop people from adopting. But one of the things that I've seen, I've been working with Ravello for not quite the 6 years, but I think probably 3 years I've been involved with Ravello one way or another. And one of the things I've seen as a big change this year is much more of a focus on enterprise production apps than more of your sort of contingent workloads like the test and development or spinning up a training environment, which prior to the Oracle acquisition was the bread and butter of what you would do with Ravello. So one of the things we're going to do in this build day is to take an on-premises enterprise application, in this case Siebel Call Center, and migrate that up into the Oracle Ravello cloud and show that the same application runs, that it's a straight upload. There's no machine conversion, there's no changes to the virtual hardware. All of that goes straight up. So unlike many of the build days, there's no hardware to deploy. We haven't had a nightmare with the network, which those who've watched previous build days know that we've had a nightmare with the network on every one of our build days previously. And so really all we needed to do this was a small on-premises vSphere environment. I'll have a quick look at the on-premises vSphere environment to run the enterprise application, and then some internet to get it uploaded to Ravello. And that all went shockingly smoothly, and so Jeffrey and I got to spend some time on the beach here in Ravello, in Tel Aviv. But
Ravello Beach is beautiful as well.
Unfortunately, we haven't had another city added on this build day. We've just been here in Tel Aviv for this one. So let's take a quick look in the lab at what we're starting from, so you understand that we are starting with just a vSphere environment. And I really should have logged into the vSphere client before I started the live stream, because of course vSphere client takes a moment or three to log on. The lab that I brought with me is much less extensive than usual. It's just a single ESXi server, little Intel NUC, and it's not running a huge amount at the moment, but we do have this one vApp that is running the Siebel application, and you can see that it has a bunch of virtual machines in it. And this is a database server and gateway and app server and all the things that make up an enterprise application. So it's a nice collection of virtual machines running to make up this Siebel app. And the way we access it is just out of a portal web page here. We've got a link to access our Siebel call center. And I can log in and see the Siebel call center application. At least I would if I could remember my password correctly, or type my password correctly. So I put 2 A's in sadmin. So this time I'll log in successfully. Once again, the way that you can tell that this is a real live build is that things go wrong. And of course I'm not a Siebel call center user, so I've just found the little pieces in here. So Kunal from Tech Marketing at Oracle Ravello has helped us set this up and shown me a little bit of Siebel call center, but we can see contact information in here and see that we've got access to a real enterprise application. So that's our starting point. We have this on-premises application, and we want to migrate that up into the Ravello public cloud. One of the things I really like about the Ravello solution is that it is all internet-based. All you need is a web browser and an internet connection, and you have access to the system. Lots of really good information here on this front portal page, this cloud.oracle.com US English Ravello page. From memory, this is also the page that you land on if you go to ravellosystems.com. Brings you to this landing page with lots of information about Ravello product, and lets us see what's going, see the insides of the product, do a bit of learning. And there's a free trial. Ravello, as an independent company, always had a really good free trial program, and there is a very similar program now that they're part of Oracle. But of course, I'm going to log in and go into the portal here, log in with my credentials, and get access to my existing environment. And the thing that I first need to do is get the Siebel virtual machines into the portal, into the Ravello platform. And at the moment, I got a bunch of virtual machines. I've uploaded most of the virtual machines, but I've got another virtual machine to upload, which is the final, the Siebel application. All of the virtual machines need to be uploaded out of your existing environment into here, although there are some templates that are built in if you want to build applications from scratch. But generally, if you bring in that enterprise application, you can use the import virtual machine wizard. And the first time you run this, you actually have to install a tool that does the import. Nice little Windows or command line tool, or also a tool for Linux or Mac. So nice collection of platforms supported. Real easy install. Just a nice little Windows installer.
Yeah. It's basically a Python script, and small one, and that's the only on-prem piece of the system.
So there's no agents to deploy, there's no other pieces of software. Log in again. Where did I put my password? There it is.
Yeah. And since I spent a lot of my professional life carrying big boxes in airplanes, I was extremely happy to build this product that has no hardware.
And I didn't do my cleanup. Naturally, we have done a dry run and we have tested things and then done most of the cleanup. But one piece I didn't do was remove the record that I previously uploaded, the file system virtual machine. So now I'm going to upload a new item now that the uploader is installed. As you can see, there's a variety of places you can upload from. Depends exactly where you're starting from, which one you'll choose. And particularly I like that I can upload my own ISOs, and I could actually start with an empty virtual machine and install my own operating system if that was the deployment methodology. But we're migrating an enterprise app, so I'm going to connect to my existing vSphere environment. And that is my VC and administrator, lab.local, my password, typo in there. Good thing I saw it before I hit enter. And so here's my vCenter server, my ESX server. This is my Siebel vApp containing all of the VMs that we saw in the vSphere client. And this last one that I want to upload is my FileSys virtual machine. And then away it goes and says we're going to start the upload. Now, it's a 1.4 gigabytes of virtual machine to upload. It's going to take some time. This is a fairly standard migration of virtual machines into the cloud, as upload of some process. The OVF files would take a while to upload or potentially download from some internet site. So why don't we switch across to a recorded video? We had the pleasure of having one of the founders. We had Benny Schneider here in the actually 2 offices down. He came across and recorded a video about the origins of Ravello systems. And Jeffrey, if you'd like to line that one up for us, that can play while we're waiting for this upload. Welcome back to the vBrownBag build day here at Ravello. I have the great pleasure of being joined by one of the founders to give us some of the stories of the origins of Ravello. So, Benny, thank you very much for joining me, and could you introduce yourself to the audience?
Yeah, this is Benny Schneider. I'm the co-founder of Ravello Systems. I was the president and the chairman of the company.
And this is not the first place that you've done development. You have a history in the virtualization community or industry prior to Ravello Systems.
Correct, exactly. So our previous company was Kubernetes. Kubernetes is the company who did KVM. That company was acquired by Red Hat in 2008. So we have a deep understanding and knowledge of the virtualization as a technology and its application.
And so you were then acquired by Red Hat, and obviously the KVM development has continued onwards there, but you must have seen some sort of opportunity. I'm really interested to hear the sort of inspiration story, what opportunity you saw that led you to actually go out and start another startup and start this particular startup. So
correct.
Nice story.
So it was Rami Tamir, which is my co-founder. He was the CEO of the company, and myself, who served in Red Hat after the acquisition for a little bit over 2 years. I was, among other things, VP of Business Development, in the sense that I had an opportunity to watch the evolution of the cloud and to see the type of challenges that cloud providers and their customers were having in adopting the public cloud.
So it was challenges around the need to completely re-architect your applications to sit on the public clouds at the time.
So at the time, this was kind of interesting. We saw a phenomena where most of the cloud provider user, I'm talking about 2011, the end of 2011, were born in the cloud type of application. These are mainly startups that have built their application from scratch to take advantage of the cloud architecture and overcome some of the limitation that the cloud was having. So I remember Rami and myself sitting in during lunch. It was in a restaurant, and we said, look, it's about time to start a new company. What are the new things that are hot? What are the things that we should look at? And obviously the cloud came as an interesting challenge and something that we should take a good look at. So we asked ourselves, given what I just told you, what are the challenges and why are big companies not adopting the cloud? So there were the regular suspects like security,
compliance,
job security, data security, compliance,
governance.
There was NIH, what it will do to my job if I'm an IT guy in a big company. But there was another one, which is the public cloud environment, is different than the private environment that people were using. Specifically, there was one feature that caught our eye, and this was layer 2 networking. Right. So apparently, the typical application of most of enterprise application at that time was based on layer 2 networking. So there was always, if you think about it, load balancer with VLAN connections to the servers behind it. And this is like a typical application that doesn't have solution in the public cloud, because public cloud, because of its architecture, doesn't support layer 2 networking.
Right. It's all, you should be using service names and discovery by lookups rather than by hard-coded locations.
Exactly. So what it meant for enterprises that even though they had the will to go to the public cloud and they overcome all the other issues and excuses that we mentioned before, it brought them to a point where they said, even if we want to, we'll have so much work to do, we better not even go there. And we thought, is there a solution that we can come up with that will make their life moving to the public cloud easy? And initially, the thought was to develop a shim layer that will sit between the OS, the guest OS, and the hypervisor of the cloud. And that's the way we started thinking about what became later on the technology behind the Ravello.
So that at that stage, it was more of a more aligned to something like VXLAN that would happen almost in guest.
Actually,
and do the networking.
We were thinking about it more from the OS perspective rather than from the networking perspective. Okay. So we thought, why don't we have a solution very similar to the virtualization concept? You don't touch anything. You take the binary as is, and you run them as is. So we realized very quickly that we need another technology that doesn't exist, basically nested virtualization, to do all this magic that will intercept the calls coming from the guest VM, and will do the magic of putting communication into tunnels and transferring them to the other side. And the challenge was, can we do nested virtualization in good enough performance to make it real? So we knew this is the problem, this is the solution, and this is the challenge. And that's what got us excited, because our background, Rami and myself, background is technical. And we said, this is a good problem to have, because number one, it's interesting. Number two, if we can solve it with a reasonable performance. So it's not if we can solve it. People were already solving the problem before. We had Turtle, IBM was producing the nested virtualization, but performance was not good enough. And there were other issues. So we said, can we really solve the problem with good enough? If we can, then we'll have a barrier of entry that other people will have hard time overcoming.
Huge amount of engineering effort to get to that point.
Correct.
To be a leader.
So we basically, from that point, we went into two tracks, if you want. One was the technical one, and the other one was the product. So on the technical one, we set a kind of a threshold from performance perspective and feature perspective. Can we do it? So we built the prototype with the help of some other good people. Like Itzik Idos was one of those guys. And we said, if this will be good enough, then we have something good going for us.
Turn into a real product. And
we can build a company around it, and we have a good solution. This one took about 3 months to get to a point where we felt that it is good enough and we can build on top of it. Sure. The technical challenge, I want you to understand, was it's not only to do it in a regular way, but to do it with the limitation that we had. What I mean by that, we were running in a non-cooperative environment. Specifically, we were running on top of existing hypervisor that was not necessarily cooperative with us.
It was never intended to run another hypervisor on top.
Correct. Or it was only intended to do one thing, to run a guest OS. And we had to cheat on the cloud provider hypervisor and make it believe that we are running a VM. So this was additional challenge that we were having.
So you had to provide something that was looking similar both upwards into the VM that you're running and downwards to the hypervisor below.
Right. Exactly. So to the hypervisor below, it should look exactly like a VM. And to the VM, it should look like an hypervisor. And that was part of the shim layer I was talking about and part of the nested virtualization that we were developing. And this brings me to the product challenge. So from the product challenge, the vision that we had was that we'll create a new entity, which is an application virtualization. What I mean by that, we'll have all the components related to running the application. The VMs, the overlay network, the overlay storage, and the dynamic behavior of the application in one monolithic entity, which we called over time the capsule.
Right.
And the concept was, let's have some very powerful operation that we can operate and perform on this capsule. So, for example, we can easily take a copy, create a copy, we can take a state, we can restart the capsule from a non-state, we can compress it if we care about cost, and we can expand it using more resources if we care about performance.
Right.
And this was kind of the roadmap from the product. And the next component that we had to tackle was the business model.
Yes.
How do we charge for it? So we said that we will build basically a virtual cloud provider business model, very similar to, at the time, we had the emerging virtual mobile operator. These are people who provide mobile operators but don't own any infrastructure. They don't have antennas, they don't have base station, they don't have fiber. They are protected by the regulator to open up the network for the
networks. Yes. We have a few in New Zealand because we're a small market, so the MVNO is a way to get into the market.
Right. So actually the leading places at that time were the European one. I was involved with some activity in this space. And there were, at that time, big deregulation in Israel. And we thought this will be a good business model to follow. But because we didn't have the regulator to protect us, we needed to have another set of features that will help bring customer to our site. And these were mainly features that we can do and the cloud provider could not. And mainly around networking. So if you look at the overall value of what Ravello was providing, it was in several areas, but the must-have and those that couldn't be delivered by any other player in the market, including the cloud provider, was the layer 2 networking.
And then, of course, you built out around it. I really liked the business model where you get one bill and it's from Ravello. Now Oracle, you don't get a bill from whichever cloud you happen to use. You actually roll that up and on-bill it yourselves. Which is nice. It's not that I'm getting an AWS bill and a Ravello bill separately, which is
Thank
cool.
you. Yes.
And of course, now that you've been acquired by Oracle, this is opening up a whole other world of business and of opportunities for development.
Right. So exactly. So I already mentioned that we were running in non-collaborative hypervisor environment. Now it's different. Now we are running on an hypervisor, KVM or Zenbase, which is cooperative with us, or we are cooperative with them, which means that we are getting far better performance than we got before. It also means that we can finally get access to the hardware resources that are available in the silicon, mainly what Intel and AMD are providing, which brings another level of performance improvement, and it can make the nested too. So once we have done the virtualization, the nested virtualization, we can run the hypervisor on top of an hypervisor and then run a few VMs. On top.
Because, of course, that was the functionality. I first saw Ravello at an OpenStack Summit a few years ago and thought, wouldn't it be wonderful if, in addition to running a hypervisor on top of the cloud hypervisor, we could run vSphere on top. And a little while later, I participated in the launch of that, and my AutoLab is now the most downloaded blueprint in the repo. And it uses multiple layers of virtualization through.
I really remember you coming along, though I didn't meet you in person, and I saw it as a good testimony, customer testimonial, that it is really viable use case for many other people to use.
Yes.
I can tell you that in the early days, I think it was like 2 years ago, performance sucked. And I appreciate you guys having the patience to work with us.
Yeah.
At the same time, we realized that some of the feature, like the ability to easily replicate design, to be able to download the complete blueprint from the repo and deploy it anywhere, was a big powerful for a company like yourself.
And the other thing for those of us who are studying and learning is that we often can't afford to own our own large lab. And so I was very used to trying to work with as little resources as possible.
Right.
And it took me a while to unwind that as I was using the Ravello platform to say there is an infinite resource available. How much do I actually want?
Right.
And that was quite a change in approach.
Thanks to people like yourself, we could carry this use case further on. And I'm glad to tell you that now, if you try the performance, you'll see the significant improvement because we are running in such a friendly and cooperative environment. On the business side, of course, we have the selling power of Oracle. So it's not only a small startup which is trying to sell its product. It's something that has far bigger footprint and far better reach within the target customers.
Excellent, Benny. Well, I think we need to close it out here. And thank you very much for coming and spending some time with us.
I appreciate it. Thank you very much.
It was really nice to spend some time chatting with Benny. He's 2 doors down in the offices and has dropped in a couple of times to say hi. Must be quite inspiring working with a serial entrepreneur like Benny, and produces a very great culture in this organization from what I've seen.
Yeah, Benny and Rami, Tamir's partner, this is their 4th startup together as founders, and they're part of other ventures as investors and board members. And it was great. We learned a lot, it's a great experience for. I mean, I've been part of startups all my career. That's what I do, and it was great working with them. First time working with such experience.
Unfortunately, Rami is in Seattle meeting with other Oracle Cloud execs, and so we didn't get the opportunity to meet him this week, but there'll be another day for that.
Yeah.
So our progress bar has been progressing. It's reporting that we're 2% complete, and well, that's not the most positive sign, but it's not actually a negative sign, because these progress bars, like all progress bars, lie.
Yeah, progress bars, they're designed to let you feel that there is a progress, not necessarily report on the exact percentage, because in many cases there's no really way to tell whether, if it shows 50%, does it mean that it's going to take the same time to complete? No, because it depends on the network, and the network is, we're now in Israel. The VM is now being uploaded into your library, which is actually in Virginia, right, in the US. Quite a long way, all the way down the Mediterranean through Greece, I think, and the UK. And
it sounds like it's a cruise liner going.
Yeah. I was hope that no one steps on the line and blocking the packets from getting through. But it's a big file, so it really depends on a lot of factors. But
so the thing I've noticed is that although it's reporting 3% complete out of 30 gig, there's in fact only 1.4 gigs to upload, and now it's just under one gig of that has uploaded. So the progress bar is showing us progress, but I happen to know for this VM that it's not nearly as long a progress to wait as you might think.
And on top of that, we're trying to optimize the upload, right? So even if your file is, let's say, 1 gig, it still might be that you need to actually upload far less than that in terms of bytes, because we do a dedupe and we reduce the zeros, the empty parts of the file. So it really depends on the way the disk is set up populated on the VM.
So it's really down to the actual data inside the VM that is constraining here. Well, the other thing that goes on, I was talking earlier with Omri about the network discovery piece, and so we have a video that talks about how the auto configuration of the networking occurs. And so what we might do whilst the last 400 megabytes uploads is to get Jeffrey to play the tape of the conversation I had with Omri about that automatic configuration of the networking. Hey, welcome back to another vBrownBag build day here with Ravello and Israel. We're digging some more into the software-defined networking as one of the core elements of the Ravello platform. And with me is Omri, who's on the team that develops this platform. Would you like to introduce yourself, please?
Hi, my name is Omri Litvak. I'm a software engineer at Ravello at the management team.
And one of the key elements of the Ravello platform is the ability to just upload virtual machines out of your on-premises infrastructure and have them work. How does that impact how the networking works on Ravello?
So when an organization want to move from its on-prem devices to the cloud, it has many aspects that it has to know, whether it's DBAs, virtualization guy, the application guy, the network architect. Here in Ravello, we tried to ease this part of the shift and lift from your own premise to the cloud. So our main goal, product-wise, was to let the user upload its VMs, and we will parse the VMs, its inner data, its etc networking.
So on a Linux system, you'd look at the network configuration scripts. And
we look
on a Windows system, presumably you're looking at the registry for IP information and gateways and subnet information.
Yes. Okay. So we took a look at the devices that configured on the VM, and from that we tried to understand and to build the correct network topology that will fit the VM's needs. So it includes VLANs, it includes the services IP addresses, the default gateway, etc.
Right, and then you're building out, by default, you're building out things like a DHCP service if you see DHCP configured,
exactly.
And routers and all of those, and access control and firewalls is being built out. Exactly. And as much as possible, that's built automatically. But one of the concerns with an automated system is that it doesn't allow me to do the fine tuning. That's not the case here, is it? This is
exactly not the case here. We try to automate as much as we can for the simple user that doesn't have any background in network or a simple background in network. But if you are an expert in network, so of course that you can edit whatever you like. You can edit the layer 2 connectivity, the layer 3 connectivity. We have an automation that will help you not to do everything by your hands, but of course, whatever you would like, you can do it manually.
So as I'm making changes to virtual machines, you're checking that I'm doing the right thing. You're doing some sort of sanity checking on the changes I'm making?
Yes, we have a great validation mechanism. Our automation works this way. When the user has any changes, like dragging a new VM to the canvas or editing an existing VM, editing its NICs or its IP addresses or its consumed services IPs, we try to apply those changes on our SDN. So when we're doing it, if we did it right, everything goes well. If something went wrong, we have a great validation mechanisms that tells the user what went wrong and what he needs to change in order to make it work.
Right, and that's exactly what I saw with some notes that I'd uploaded a VM and it was on a network that didn't exist, and so I'd incorrectly, or the network IP, the IP address had been incorrectly identified on it, and I needed to make changes to it so it fell inside a subnet.
Exactly.
Nice. Excellent. Well, thank you very much for uncovering a little of the automation that's underneath the networking stack, Omri. Do join us for more of the vBrownBag Build Day with Ravello videos, and watch for more great stuff from vBrownBag. So during the upload process, all of that network discovery goes on. That's a pretty cool feature.
Yeah, that's it's one of my favorites. It's I mentioned before that one of our design goals was around simplicity, and I spent many years as a product manager in enterprise IT companies, and I know that one of the barriers, bigger barriers for a product, is the fact that when you come to deploy a product, you usually need to get the help of multiple different functions in the organization, right? So your user or your customer might be looking at a product I've built 10 years ago, might be the security guy, but you need to get the network architect to give you a span port, and you need to get the data center guys to give you a slot in the rack, and you need to get the application guys to explain how the application is set up, and then the database guys to give you the database details, just to install your security sniffer that kind of look at the traffic.
4 or 5 different teams just to get this one thing.
Yeah, and they usually don't, I mean, yeah, everyone cares about security, but it's not their main job, right? It's the security manager.
Being the security guy is a hard road because you're the guy who wants the know. And
I've been flying back and forth from Tel Aviv to San Francisco twice during 1 week with a big server, just because I got to a customer and the networking guy said,
we're not ready. Take it away.
Now, send me the diagrams and send me all the documents and we'll talk about it. So first we were very happy that, I was very happy that this product doesn't include any hardware, but I really wanted to build a product that doesn't need the help of the other functions in the organization. And when you want to create a replica of your environment, your production environment in the cloud, it's very complicated, right? So you need to understand the virtualization aspect. So which are the VMs and what are their hardware, what is the hardware configuration of each VM? Then you need to understand what is the network configuration, what are the IPs, what is the topology, DHCP details, and so on. And then you need to get the application details. So you need to know you have a web server that needs to talk to a database. So what are the IPs and what are the host names? Each one of these pieces is a different function. And we wanted to build something that would be bulletproof. So you get the one function in the organization. In many cases, it's not even the virtualization admin. It might be the QA manager, or just the owner of the application. And you can just point to the VMs and upload them to the cloud. Obviously, you need to get access to the vCenter. That's the one barrier. Yeah, and you need to get the agreement for everyone. But you don't need, for example, to know exactly the network topology. You don't need to know which VM is talking to which VM over what IP and what is the IP configuration of each of the virtual machines. We extract all of that out of the VM configuration. And the network is one of the biggest magic, I think, that we developed. Because we really wanted you to be able to upload your VMs and then drag them on the canvas, and the system would understand or magically figure out the network topology exactly as is and build it automatically. And it works like a magic. During the first years, the first implementation was, I mean, it was a magic, but there were limitations. And the second implementation that we released a couple of months ago actually enhanced it and adds more capabilities.
Yeah, and I've certainly seen a much richer networking exposed out through the portal, and we'll have a look at this a little bit later with one of the interviews that I did with Amit. But our upload has finished. It didn't take forever the way the progress bar initially told us it would, and so we now have our uploaded virtual machine. What do I need to do to get my Siebel working now in the cloud?
So let's go to the Ravello UI. Now your virtual machine is in your library. It's basically a library item. When you upload it, you need to go through a short process of verifying the VM details. As I mentioned before, we parse the virtual machine. We don't change anything on the disks, but we do read the disk to try and understand what are the IPs, sometimes get the VLANs and other pieces of the configuration extracted and put it in the metadata of the VM. So the process here is just you go through a wizard just to approve the details that we automatically extracted. And if there are changes, you can just
so it's got a gear icon here saying there's work to do, and edit and verify the virtual machine. It says what do you want to call it, and I'm just going to click the finish button. I know it's right. It was a good VM. It's imported nicely.
It's an amazing system. It always reads the correct details. So
yeah, so we can see in here in the network adapters that it's got a static IP address, and we can see the details of that static IP address on the sphere. It's all nice and easy. All right, so now my VM has got a green tick. That's got to be good.
So now your VM is in the library. You obviously have the rest of the application VMs, and in most cases now it would just be enough to create an application, basically an object, and then drag your virtual machines on into the application. And in most cases you're done. Sometimes you need to do a few more extra.
Let's see how well it did on discovering these VMs. We'll just create our application, and this is my Siebel call center, and I'm just going to create that as a nice empty VApp. And now we've got this canvas, and I really like the canvas. I'm a visual person for relationships between objects, and so I love the canvas, and the network diagram in here as a way of seeing what it is this bunch of virtual machines is. And of course, drag and drop. So there's the VM I've just uploaded. I'll throw him in. And there's a database virtual machine as well. There's two between them at the data tier in my application. I've got an app server and a gateway server, which is the middle tier. And then I've got a web server that's the front tier. And that's the 5 virtual machines that actually make up the Siebel app. There was a 6th one in my vSphere environment. That was just a firewall that provides access, and I'm going to use Ravello's built-in functionality for the firewall.
But if you did to, you could have bring your firewall as well. Create, if your application has multiple subnets, so you can throw the firewall in between to separate between them.
Right. Just as you would in an enterprise deployment. All right, so on other things that I need to do. This app, I needed to provide access from the outside. How does that, where am I going to do that?
So one thing about the network, as I mentioned, we automatically figure out the network out of the virtual machines. You may want to go and see whether the network really fits the on-premise network, or you want to do changes. In most cases, the system knows how to generate the network out of the configuration. And now when you publish your application, your network would be fenced, because your network is basically a copy of your on-prem network with static IPs that are not supported in the cloud, and you want to run it in the public cloud. Plus, you may want to create multiple copies of your application in the cloud. So you need your network to be fenced from the outside world. But you do need to get to your application, so you need to create entry points in your application. Those entry points are services. We call it supplied services. So this is the entry point for the application. It is basically nothing grew. So you would like to access your front and your web server through a specific port. So you create a service on that port, defined as an HTTP or HTTPS service with the port number.
Port number. So my web server is the front end, and so that's where I go and add a supplied service, and I'm going to call it CC for call center. I've only got one IP address on my web server, so I'll use that one, and it's going to be HTTP access, but it's on port 7777 instead of the default 80. Cool.
The protocol there is just a hint. It helps you understand what is the service that you open up there. You can also pick up TCP or IP and be more specific, but HTTP is good because it also tells the system that this is an HTTP. The UI would provide a link and so on.
Right. But if I was doing something like opening up an SSH connection, it's predefined, and RDP as well, I see also predefined in there. Now, the other thing is that, like a lot of applications, there's a startup order that's required. There's a series of dependencies. I understand I can configure the dependencies in the startup order in here as well.
Yeah, exactly. So many enterprise applications applications require. Startup order, right? You want your database to start before the others. You want your Active Directory to start before the other components. So you can go to the Settings tab. And on the right hand, there is the Add Stage component there. And you can start add stages and define the time interval between each stage.
So my first stage is the data tier. I can create a stage over here on the left because I've got a second stage, which is the app tier. And I need a couple of minutes for that one too. And then my final stage is the web tier. And I don't need to wait after starting that. All right, so I've now got my tiers, but I need to...
So now your VMs are at the top bucket there, and you can assign them to the different groups.
All right, put the app there. Okay, so once they're assigned to a tier, they clear out of this list, so I can at least see which ones are assigned to a tier and which ones aren't, which is nice. Gateway is in the app tier. The web server, funnily enough, is in the web tier. And the file system is also in the data tier. I guess I better save that.
Great. So now we have
the list of VMs. You can see them on the canvas in a way that makes sense to me. And then there's that networking.
Yeah. So that's the networking. The VMs that you uploaded were all with static IPs and on the same subnet as the network detected there. There is an additional subnet there that's a DHCP subnet that the system creates by default in case that you have VMs that are part of DHCP that they would be added to this subnet, but in this application there is no use for it. So
right. And there's areas at the bottom it's a little hard to see on the screen that are for DHCP servers and DNS, and so there's a series of functions that are built into the platform that I could use. Yeah.
So in order to create a copy of your on-prem network, you would need to have the typical network devices, which would be a set of switches, obviously, but also a router, which you can see there. There's a DHCP server and DNS server, and there is an IP filtering, which is a component that sits at the entrance to the application and allows you to set some basic security rules to the application.
So that looks fairly extensive, and we do have that a couple other videos that we'll dig into that one a little.
Yeah.
Jeffrey, you got something for us? You got a question out there?
Yeah, we got Keith is on, Keith Townsend, the CTO advisor. So he's asking, what happens with encrypted disks? Does network discovery still work when it comes to that?
No, it won't work because if you don't have the keys, we cannot decrypt the disk itself.
And hi Keith, great to have you watching. And also Keith, CTO advisor, is one of our close friends with the build days, and he has helped us make better build days. So great to see you, Keith. And I hope it's not too cold in Chicago. So now we've got our application defined. Surely I need to start running it.
Yeah. So now we have an application in a draft mode. So it's basically just the definitions of the application.
I got a picture of the app. Now I need a real app.
Yeah, exactly. Now we want to instantiate. It's like an object class and an object instantiation of it in code. So we want to publish it to the cloud. So we can click on the
publish button, I guess.
Publish button, yeah. And now there are two options. There is a cost optimized mode and a performance optimized mode. The cost optimized mode is where you basically want to optimize for cost because you care less about the performance. It's you want to just test your application, run some basic workloads, and see that it works. In this case, you don't get to choose the region in which your application is going to run.
It'll just be wherever it's cheapest.
Yeah, we're going to pick up the cheapest option, and we'll do some optimization in the backend that would allow us to provide it in a lower price with some compromise on performance. The other option, the performance option, If you click on it, you see that you get a list of regions in which you can actually deploy your application. There's a long list there with pretty extensive coverage all over the globe. And you can just pick up your region. Let's go for US East 5.
And these regions are spread across multiple different public clouds. We're choosing East 5 because that's one of the Oracle Cloud data centers, and of course,
this is the Oracle second generation cloud, and in Virginia, in the center of or East Coast in the US. But we could have picked up other regions in different places, and we currently run on Oracle Classic, which is the first generation, the second generation of Oracle Cloud, AWS, and Google regions.
Great. So lots of options about where I could run with different cost implications. We've also got this schedule the application to stop after 2 hours, which seems like not what I want for my enterprise production application.
So obviously when you run production, you can pick up never, right? That's an option there. But when it's not production, you would like to pick up never because...
How about because if this was a production migration, we would choose never, but we don't think this build day is going to run for more than 4 hours from now, so let's go with a 4-hour run. And of course, being a cloud service, you're paying for the hours that it runs.
Yeah, exactly. You pay by the hour. This is why we provided these options, because customers that told us we don't want to let our developers or trainers or SEs or basically the users just go wild and run the application and forget them forever in the cloud.
Even Alistair was saying when he was done with putting something together, he would instantly try and turn everything off, get it back to the state, and so he wouldn't take up too much time on there.
It's a sort of default response for me is it's sitting on cloud. I need to shut it down as soon as I'm finished with it. And since Ravello Systems days and now with Oracle Ravello, Ravello has had a really good program of supporting the VMware vExperts, and all of my access to the Ravello platform has been through that program, where I get a amount of resource every month, and that allows me to run labs. And so we can see, as I've dug into the detailed pricing here, the total price is struck off, and I'm being saved, what is it, $1.28 an hour. $1.28 an hour to run 5 VMs with 10 CPUs. That seems pretty cost effective.
Yeah.
So I'm just going to hit the publish button on there, and our glasses turn up. I guess there's some stuff going on.
Yeah. So now the process is such that the system would take the overall configuration of the application and try to fit it into the right cloud instances. There's some feeding algorithm that decide which cloud instance is appropriate, or a bunch of cloud instances are appropriate for your application, and how the VM should be spread on the different instances. And first step, the system would allocate an instance and the rest of the infrastructure that is needed, networking, disks, and so on. Once we get all the cloud infrastructure set up and our OS is booting with our code on top of it, we will start the booting of your guests. In this case, we have a start order, so you can see that there are different icons on the VMs. So 2 of them are scheduled to start first, but the entire cloud infrastructure is already in place.
Stood up for them. Yeah. And I did record a video with Inav about what happens during this process. So I think while we wait for this migration across, we run the what happens when you deploy the video, please, Jeffrey. Welcome back to another vBrownBag Build Day video here at Ravello in Israel. For this video, I have 2 guests. The unseen guest down here is Shanti. And you just see a little bit of a nose, so I'm just patting Shanti down here. This being a real startup, Pets are welcome, and Shanti here comes and visits. And she comes every time you're here, Anna.
Yeah, sure.
Can you introduce yourself to our audience?
Sure. So my name is Einav, and I work at Ravello here for about 6 years. And what I do here is I'm one of the team leaders of the backend. We have 2 of them, so I'm one of the team leaders. Yeah, that's it.
So the backend is all the things we don't see in the user interface, but that are being driven by the requests out of that.
Sure.
And we particularly wanted to talk about some of the things that happen when we take an application and we actually deploy an application from a blueprint and all of the magic that happens underneath to allow that to deploy out to wherever it is we've chosen. And that's one of the things you've been working on pretty hard over the years.
Right. So that's like one of the main things in my team that we were working on. So do you want me to tell you a little bit about how it works behind the scenes?
Yes, indeed.
Okay. So what we do when someone publishes an application, whether it's from a blueprint or just library VMs that they dragged into the canvas, what we do at that point is we're basically a virtual cloud provider. We're not a real cloud provider. We don't have data centers. So we use the APIs of the real cloud providers such as Google, Amazon, Bare Metal Cloud, which is now OCI. It's called OCI. And we take a host, which can be bare metal or a virtual VM, virtual machine. We take volumes, we take external connectivity components for our public IPs that we supply the guests.
Right.
We build it all together. And on top of it, we install our software, which is both the virtualization, the hypervisor, and then also the SDN, software the network.
And the storage
and the storage
elements.
Right. And then we configure the actual guests, like the actual specific devices that we are asked.
What we have configured in the canvas, but below those VMs, there is this HVX hypervisor running in often VMs on top of the cloud provider.
Right, right. And when I talk about devices, I mostly mean like the actual cards, like the actual
down
devices.
To storage device,
right.
Network adapter.
So, exactly. So you have different kind of devices, if it's a SCSI or if we're talking about IDEs or whatever network or storage devices, we support quite a few, quite a big range software that we developed here to support most of it. And then we configure it on top of the actual infrastructure that we're given by the cloud.
The cloud provider.
Yeah, using our own software. And that's pretty much it. So you got a running VM on top of everything.
Right. So a collection of devices for each in the same way that any other hypervisor is producing that virtual hardware. And then you take a fairly large cloud instance in order to run my collection of virtual machines. You don't run each one in a separate cloud instance. You actually tend to take...
we consolidate.
Is that just that there's a universal largest size, or do you do best fit?
Okay, so
best size fittings?
Okay, so we do have some sort of fitting algorithm. We calculate the needs of each guest, if it's public IPs or CPU, memory, size of the disks.
Shanti is just catching the cable here.
Yeah, I hope I'm still being heard. So CPUs, memories, and all the technical aspects of the hardware, the virtual hardware of the guest, and we combine a few. We take a few guests of the same application together because they're most likely be started
Talking
together
to
and take
and,
exactly. And we deploy them on top of a bigger host.
Right. And multiple hosts for very large. We talk about one of your clients who uses hundreds of virtual machines in an application that's going to necessarily have multiple of these hosts.
Right.
And then you do some things around persisting changes because, of course, the long-term persistent store is on object storage, but the transactional is on block storage. Can you talk a little bit about what happens when I shut down my VM?
Sure. So what happens there is that behind the scenes, we're taking a snapshot of the state of the guest. we take a snapshot and we upload it to the S3 or whatever that means.
Object storage we're using.
I had some Hebrew kicking in. So we upload it to there, and then we remove the guest from the host. Once all the guests that were running on that host are down, we can shut down the host and release all the volumes and the external connectivity and all that. And so that's basically the process.
You don't reuse those hosts at all? There's no efficiency to be had?
We do reuse them, but only if the application is still up. Okay. For example, if you removed one guest, another guest might come in instead. But if you remove, usually people delete or stop the entire application, because the application represents not a data center, but like a service. Yeah. So usually they all go down together. So that architecture matches with that.
Well, thank you, Aneth. That was really interesting to hear what goes on underneath all of the pieces of the cloud of clouds, as I refer to Ravello as being a cloud of clouds. This has been another of the vBrownBag Build Day videos from the Ravello Build Day. Keep watching for more. I really enjoyed having Shanti here in the room with us and also seeing her through the week while we've been here. And she pops her head up a little in that video, which is really fun. Excuse me, really fun. One of the things Jeff and I both noticed is that we've spent time with startups in Silicon Valley, and we come here and we see a lot of similar aspects, that there seems to be a very similar startup culture here to what we see in Silicon Valley. What's your experience been with the startup life?
Yeah, so I'm in this business of almost 20 years, and obviously all Israeli startup companies has a representation in the US, mainly in the Silicon Valley. So it's always kind of a dyad, like something that lives on both sides of the, not just the ocean, it's 10 hours difference.
Time difference.
So, yeah. So the cultures are, I mean, there's a lot of similarities, right? Because the same companies spread across. There's some aspects of culture. You know, the Israeli culture is extremely different than US culture. At least, you know, the language, not just the language itself, but the way we communicate. So there's usually a process of getting to know each other. So
Israelis are known for being direct and forceful in opinions.
Yeah.
And as we've
hear what I have to say. So, but it means the same. I mean, it's not impolite. It's just like, this is the way it comes out.
The societal acceptance is the same.
Yeah. So it gets time to learn each other. But the culture at the end, it's the same in the company. The weather in the Silicon Valley is much better. That's
it doesn't get quite so extremely hot. One of the things I've really enjoyed is the food here, both out and visiting the restaurants, and Gal's given us some great recommendations of restaurants that we haven't actually been able to go to nearly enough of. But also even just the food that's provided here in the offices is hummus and fresh vegetables, and that's unprocessed, very natural food, and I found that it fits me as a New Zealander to have nice, simple foods.
Yeah, Jennifer's been saying that we have to go to Tel Aviv just so I can start eating healthy. So that was a good thing, but it's been great to come here and have a lot of variety of food. That's for sure.
Yeah, food is a major theme in Jewish culture in general, and Israel is a melting pot of many different ethnicities and groups, and everyone brings his own food, and everyone's very proud with his own food. So this food is central, and you know, it has to be good. I mean, if there are not enough yogurts and there is not enough diversity in the yogurts in the fridge, it's a good reason to quit and move to a different company. And it happens to me in the past, not here in Ravello, but in different companies. People say, "Oh, there is no chocolate yogurt anymore. I cannot tolerate it. Yeah, I'm going." So
So there is some difference to Silicon Valley. The things that cause people to throw their toys out of the cot are a little different.
Yeah.
Now our Siebel app has started up, so I guess I should do something with it.
Yeah. So you can try and browse it, but let's to begin with, let's see if it's.
Well, what I've got set up is in my lab environment, I actually have a URL in here which points to a DNS name, and that DNS name points to my current virtual machine. So if I open this this link, I get the Siebel call center, but running in my on-premises data center. So I thought what I would do was actually shut that down. So actually take my on-premises copy of Siebel, and I'm going to shut it. I'm going to power it off because that's going to be quicker and nobody needs to see it shut down anyway. It's my old copy. Now my real copy is up in the cloud. So what I should find then is that when I launch this link, it's not responding because I powered it off. So I was going to grab the IP address of the public IP address of the web server and change my DNS record so that link now works with the local one.
Yeah,
and it looks like just here on the properties of the virtual machine, I can see its public IP address.
Yeah. So since we defined a service on this VM, it basically creates a NAT rule from the public IP that we assign to the specific VM to the static IP that is in the internal network, in the fence network of the application, just for the specific port.
Okay. So if I grab that IP address, and I go back into the RDP session I opened up earlier to my domain controller, which is my DNS server. I really should have cleaned up it. Somewhere in here is my DNS. There it is, and there's my call center DNS entry. And I'm just going to change it from my internal 192.168.199 address to the cloud address. Alright, that's been done. Let's see if I have to flush DNS on my client machine again. It's going to go out. Might still be trying to reach the 192.168, so let me just close that one, open up a command prompt, and do an ipconfig /flush DNS. That'll get rid of the 199 address out of my DNS cache. And let's try again. Open link in new tab. What I should do is just check that that DNS change has come through. Ping, paste. Yes, so it is coming through, so my DNS is right.
So another thing we should do before we shut down our production environment is to actually see that the VMs are booted, right? They completed the boot process.
So up here in the Ravello environment?
So we can go to the Ravello UI, and one of the nice features is that we have a console access to the VM.
Okay.
This is like really a hardware console.
It's a VM console the same as the VMware VM console?
Yeah. So even if there is no network, you still get a console. Actually, you can get a console to an empty VM and install a CD from scratch. So let's see how the console looks like and whether we completed the boot.
Well, I can see that my Siebel Call Center app has actually opened up in that second tab while the console is loading. Taking a moment or two to load the console. Let's pop back. There it is. There we go. My web server is up. I'm sitting waiting for a login, and now my Oracle Call Center application sitting up on that Siebel machine. And so if I can remember to type my password correctly, and that's not where I wanted it. I want to put my user ID in here.
That's always the big challenge.
Typing things correctly while dozens of people are watching on the internet is always a challenge. Typing things correctly is a challenge for me when there's nobody around.
This is why the best password is 126, right?
It is the easiest password. And it looks like my Siebel application is loading just the same. And there we have, there it is, loading up. hasn't taken us terribly long to take an on-premises enterprise application with a whole heap of database and middleware and all of these things is now up and operational. And other than that, I had to refresh the DNS at the client side. I didn't have to do anything in this case. If I'd made this change overnight while people were out of the office, they come in the next morning, the DNS record has been updated, and now they access the application through the same URL, and it's now in the public cloud.
And that was our goal, and that's what we're proud of, and I think that this is the reason that we succeeded with this product, because it has to be simple. Otherwise, it just cannot work because of the multiple functions involved in building and defining application, because the knowledge is never in one place. It's really hard to find in an organization someone who knows the application configuration, which DNS names to use, what are the IPs, what are the VLANs, and how it's set up. In many cases, it's very hard to tell even which VMs are part of of your application.
You do need a discovery tool. I mean, not knowing how your application works isn't going to be fixed by this migration. But,
that's true. But
the minimum knowledge is
going
to be required, and much less coordination with other teams than you would for on-premises deployment. Well, I think that's a pretty cool thing, the ability to pick up unmodified vSphere virtual machines, push them into the public cloud, and run them. What other things could I do with these virtual machines, this app, while I have it in the cloud? We've got a blueprint functionality in here, which I think is pretty
so
cool.
Now we have the application running. We tested it. It's working the way it's operational. If we were doing shift and lift and lift and shift and moving it to the cloud for production, great. Pretty much done. But there are many other use cases that are non-production. Actually, as a startup, we focused mainly on the non-production use cases, just because it's much easier.
Early on, it's easier to get.
Yeah, it's easier for a startup to come and
trusting people with your crown jewels, your Siebel call center, which is managing all of your CRM. That's not something you do the first time you work with a startup that's new on the scene.
So, but there are other really cool and important use cases. For example, test and dev. Internally we use Ravello for test and development a lot. We have a concept of babushka, we call it, which is basically the doll inside doll.
That explains why there's so many of the Russian nesting dolls around the office.
So it's basically a Ravello inside Ravello. So we have a blueprint of Ravello. I mentioned what a blueprint is. And me as a product manager, if I want to see a new feature, I can spin up a whole new Ravello just for myself, right? Which has the same UI, same functionality, but it's just the newest code that is not rolled to production yet. Our automation team is using those babushka to integrate it with Jenkins and with the CI tools. So every time there is new code pushed by the developers, it's being pushed into a replica of production, basically, and being tested on top of it. If a developer needs to have an environment to test something, he has a copy. And it's really, really important, and we've seen it in many cases, that you run your test on a replica of production. This is
a full replica of production,
full replica. This is a mantra that we keep on saying all the time, and we've seen, actually, one of our customers had a problem just a couple of days ago. They were testing their scripts and things were working fine, and then they rolled the version to production and things failed. And we thought, this is because you run your tests locally on your laptop.
Not a full
and they're using Ravello, but this was one of the systems that they're using in order to use Ravello. So it's like a side system. You have most of those production environments, right? They have multiple parts in the multiple virtual machines, right? And in many cases, when people run their tests, they're basically combine them all into one VM. And then you eliminate the network aspects and the effect of the network, and the configuration is different.
You make changes along the way to accommodate that consolidation. So your test environment, because you've consolidated it, no longer reflects your production environment.
Yeah.
And you often do that because you're short of resources, that you only have a limited amount of resource for your for test environment.
Yeah, almost always because you are short in resources. And it's amazing. We visited big enterprises, big companies, very successful, and you ask people, how do your test and dev environment looks like? And they say, we have one environment for testing for the developers, which is usually really small, like one server, and there is one environment for testing, for acceptance tests and so on, which is not exactly like production. So okay, we have like 3-4 virtual machines, and we asked them, there any problems because of it? Yeah, all the time.
All the time, because it doesn't match production.
Yeah. And the cool thing about it, and it was, again, one of the first use cases that we focused on, is that now you can just like spin up an entire copy. Our Babushka has, I don't know, I think 15 VMs. It changes all the time, right? You spin it up, run your test, shut it down after 2 hours. It doesn't cost much, like a few bucks.
Yeah.
And that's it. I mean, it's full copy of production.
And that was when I was doing some work a couple of years ago with Ravello around my auto lab. The change in attitude that I have access to infinite resource, essentially, compared to how I developed AutoLab, which was I have almost no resources and I have to make everything squeeze in. That shift to I have available to me near infinite resource, and the incremental cost of doubling the size of the environment I'm building is not actually as big a change as it is if you're buying hardware for it. It's much easier to work and to scale these things out. That required a mental shift for me.
Yeah. Yeah, because when you increase your resources, when you buy more hardware, it's okay, you can double your capacity, but you always run out of capacity. I mean, so you get hit again. When you have unlimited capacity and you can burst, this is where you can really implement processes that drive agility. This is where you can really do things. This is where you can do really continuous integration and continuous deployment, because you can first deploy to a copy of your production, then roll it to production. It's really amazing. And people who are basically cloud users by nature, that are building their production environment natively on the cloud, they say, yeah, it's easy. We have implement a copy and with different DNS and so on. But when you work on-prem in an enterprise environment, you just don't have this luxury. And with Ravello, you do. Yeah.
Now, the next thing we're going to do, I've realized I've missed a step in my preparation, and we may have some fun as we go along here. The next thing we're going to look at is some of the performance improvements in the move to using the Oracle Cloud and some of the more advanced features of the other clouds. And this was about CPU performance, essentially, was what we're going to spend some time on. And I've just realized that I've not started a performance test that we needed to have running. So I'm just running that up now. And as soon as I get that running, we'll talk about what it is that we're doing with CPU performance. So just talk amongst yourselves as I start these.
Yeah.
Really quick, I just wanted to show you, because these are all around the area, and this is what they're talking about, the little nesting dolls. And so I have to apologize to Gil because he has this on his desk, and we're in Gil's office. So, but anyway, so basically it's a nesting doll. So you open it up, and there's another one inside, and you open it up, and there's another one inside, and there's another one inside, there's another one inside.
This is actually funny because this is an Indian version of it, right? If you look at the figure,
the figure on
oh yeah, you're right.
There's a sari, and and the other one is more of a Russian figure.
This was the closer one, so
yeah. So on the performance tests, so we're going to talk about
So Well, one of the things that was really big in the new release this year was the ability to do much higher performance. So as we discussed, the starting work was around test and dev environments, and I feel it kind of reflects the development we saw with hypervisors over the life of that revolution. That initially it was test and dev environments and relatively small environments and virtual machines, but over time, as the awareness of hardware got pushed up through the hypervisor and the requirements of the hypervisor got discussed with the chip vendors, we got more capability, we got better performance and more scalability on the hypervisors. I see a big parallel to what's happened in the last year with Ravello. Can you talk a little bit about how that's happened?
Yeah, so early versions of hypervisors were, I think the very early versions were emulators, and then there were hypervisors doing binary translation. I was actually involved in building a binary translator in '95, I think, working for Intel. Binary translation is great technology. Basically, you take the code, the machine code, translate it into a different architecture. In this case, it's the same architecture, but you want to protect from the kernel calls, moving into the kernel, into the DOS, and you run that on the cloud. The next generation came when Intel and AMD presented their instruction set that supports virtualization, and there they solved many problems that impact performance for virtual machines. So, for example, the synchronization of multiple CPUs, right, which is very hard work because the number...
And that, of course, was required when they realized they couldn't keep running gigahertz faster. They had to put more cores inside each socket, and so they needed... we got these massively parallel systems, and the feature set being pushed through into the virtual machine improved.
And other features were basically accepting the fact that there is an hypervisor, because the early versions where virtual machines were basically the same as the physical machines in the sense that they used drivers that were designed for physical devices, right? So the hypervisor needed to emulate the physical device. But at a certain point, people said, okay, there's an hypervisor below, and we can do much more if we are aware of the hypervisor, right? So I/O doesn't need to go through software emulation. We can speak directly to...
We don't have to have the virtual machine think it's talking to a physical switch, because it's actually just talking to a chunk of memory, so it doesn't have to serialize and segment the way that it does. The funky thing was in the early days when it was all emulated, you get this segmented data coming out of the virtual machine that was reassembled by the hypervisor and then segmented again by the network adapter that was physically in the host. And this is where the para-virtualized drivers come in and take that double handling out.
And the nice thing about it is that the OS stays the same, because as far as the operating system concerned, there's a driver, right, that's dealing with it.
It's just a network driver or a storage driver.
And now the driver is designed for a power virtualized device underneath. So we went through the same evolution. Actually, the biggest challenge for us at the beginning was the fact that cloud providers does not expose the hardware assist, the instruction sets.
So it's the Intel's VT and AMD's V instruction sets.
Yeah, exactly. So you can run a virtual machine on top of the cloud using the cloud hypervisor format. The virtual machine should use the power virtualized devices of the underlying cloud. But if you want to take your VMware VM or your on-prem VM and just run it in the cloud,
you've got to emulate the para-virtualized device, and then so VMware typically use a para-virtualized network adapter, although not so often the storage. But the Ravello platform has to provide the underpinnings for that para-virtualized, even though the underlying, there's another hypervisor in the cloud that's presenting up its own.
So the challenge was to build a hypervisor that runs on top of another hypervisor, but cannot use the instruction set.
So it runs there without the knowledge of the underlying hypervisor.
without the knowledge of the underlying hypervisor and without the help that you get from those instructions that are designed exactly for that. So that was the magic. I think that Benny talked about it. That was really super smart. People just couldn't believe. You know, at the beginning, people say, "No way, it's nonsense. It's not going to run."
Yeah, as I said to Benny, I was blown away when I first saw it at an OpenStack summit when Manisha demonstrated it. Was just can't believe this works.
Yeah. And then it was on the OpenStack Summit, it was where we introduced the capability to run another hypervisor on top of it. So you have the cloud hypervisor, and then you have the Ravello hypervisor, the HVX, and then on top of it you have KVM for OpenStack or ES6, right?
Yeah.
And people say, okay, that's like too much.
So three hypervisors deep.
Yeah. But it worked in relatively great performance for, you know, the conditions, much better than anyone else could imagine. But nowadays, when we're part of Oracle, we actually, on the cloud, you know, we're on the Oracle regions, we can actually benefit from the fact that we are part of the cloud provider, and we can actually use this hardware assist functionality.
So you can cooperate with the cloud rather than working despite the cloud.
Yeah, exactly. And that allows us to provide much better performance. And it affects in different layers of virtualization. One of the most important one is the number of CPUs or the CPU power, because in an hypervisor, and not just in an hypervisor, also in the real hardware, right? When you increase the number of CPUs, your performance doesn't increase linearly, right? Yeah. Because you need to synchronize between the CPUs, they need to access shared resources and so on. So it's not linearly. And when you have another layer of hypervisor and another one on top of it, the synchronization becomes very hard. And part of the those hardware assists, those instruction sets that are provided for hypervisors are there in order to help the process of synchronization. And so without the hardware assists, we wanted to stay limited to up to 8 CPUs. We could run more than 8 CPUs, but then the performance is just too much.
The benefit of an additional CPU gets eaten by having to synchronize everything.
Yeah, and now we can use hardware assists, so we can go higher the number of CPUs and we can better utilize them and provide better performance.
All right. What has gone on in my environment? Yeah, we didn't want that. We should just have this guy up. That's right. We don't particularly need to see. So, what we're doing in the we will take a quick look at the Ravello level. So I don't need all of those ones there. We just need the Ravello piece. And you may have seen when I created the Siebel application that I already had 3 applications running. So this is 3 copies of VMware's Weather Vane benchmark, which is a nice general purpose benchmark that loads out all of the resource types and tells you whether it emulates a web auction site, and it tells you at the end whether your web auction was running successfully or not. And we're using it, and you run it for a particular number of users connecting to the web auction. It's a pretty cool little benchmark. We're running it in the 3 different modes. So we're running one copy, the one at the bottom of the list is in binary translation mode, which is the oldest way and the one that works in the most places. And then we have the top Weather Vane one is called hardware. That's the one where we're talking about having that hardware assist, the VT instructions being passed through. And the middle one is bare metal. Yeah. What's that option all about?
It's actually better than the hardware assist. I mean, it's using hardware assist, but so the second generation Oracle Cloud provides 2 flavors of machines. One is a virtual machine, and the other one is a bare metal machine. So you can provision a whole host, the whole bare metal. And for us, this is great because, I mean, we always dreamt of, you know, being able to control the hardware so we can install everything on top of it. And this is like really one layer of virtualization, and this is where we can squeeze the most performance possible with a hypervisor. And
so this is the Ravello hypervisor directly on bare metal, no other hypervisor in between, in the same way that other hypervisors are installed. So it's taken away the magic of running on top of another hypervisor, but left the magic of taking unmodified VMs from your vSphere environment.
Yeah, exactly. People told us, if you run on bare metal and you have the hypervisor, so what's the deal? But there's a lot of smarts on top of it, because I mean that was really a magic, and no one believed that we can run another hypervisor on top of the cloud in great performance. But there are a lot of smarts there as well. There is obviously all the different devices that we built and contributed to the KVM and QEMU mainline, and there is all the SDN. There is all the capabilities around like building and defining an application. There's a lot of smarts there.
Good, and we're running that weather vane benchmark, and I've started a run for 1,500 users of the weather vane benchmark. Actually, it's away, it's running. It's going to takes quite a while to run a good benchmark, and weather vane is a good benchmark. We've got it fairly tightly down that it doesn't run for hours, but it still runs for quite some time. It's running in these apps. These three apps are exactly the same. They're deployed from the same blueprint that, again, Canal provided for me. And there's, as you can see, what have we got? 7 virtual machines there. And each of the virtual machines is 4 vCPUs, 8 gigs of RAM. So it's quite a lot of resource in each of these runs. But they are taking some time to run to tell us how the results are.
So benchmarking performance is, it's always complicated, right?
Oh, yes.
Because people say, we ran, it's just like, IO tests, right? And we see the number such and such. But, it doesn't mean anything. Benchmarks are performance in general. It's really dependent on so many components. I mean, there's the CPU, but not just the horsepower, the gigahertz, but it's also the way CPUs synchronize between each other, and the memory access to the CPU, and the memory itself, and then the disk access, and then the multitasking inside the application, because you have in a real life scenario, you have users hitting your web server, and there are multiple things happening at the same time, and then there's a communication. It's really, really complicated. So the right way to measure performance, and whether the performance is right for you, is to take your application and run the workloads that you're going to run. That's the only thing that would give you
the final test is real users doing real tasks with real data, and everything else is a facsimile, and that's essentially what we're doing here. Is not benchmarking a real application, but allowing us to show a comparative performance across the different platforms.
Exactly, but with a real application that has multiple components and is doing like real life.
It's not a synthetic workload. It's a real application representation workload, which is the nice ones for running benchmarking. While that benchmark runs, I think it's a really good time for us to get a little break from being on camera and to hear a little more about the CPU components that Amit talked with us on. And we've got quite a few videos with Amit, and the first one that we'll run up is the CPU one. Welcome to another vBrownBag Build Day video here at Ravello in Israel. I'm joined once again by Amit. Welcome, and thank you for joining us. Now, Amit, you're involved in the development of the Ravello platform, and we wanted to have a little look at the different ways that CPU is presented up into the hypervisor, the HVX hypervisor, and particularly as things have progressed, there's been a lot of performance improvements with the changes to how the CPU is presented up. Can you just run us quickly through the different ways that the underlying hypervisors send CPUs to Ravello?
Of course. So when we started, we had to develop our own hypervisor. It is called HVX. And it is optimized to run on top of other hypervisor. We use nested virtualization to allow running seamless workloads from the on-premise virtual environment on top of any public cloud. So the HVX was kind of a translation layer for us, an abstraction layer. So we had to develop it from scratch, okay? And it worked by using binary translation, which means that we had to look on every instruction one by one that the guest was going to run and decide whether it is safe to run or whether it needs to be changed. Okay, it is a familiar technique with many hypervisors, binary translation.
And this is where most hypervisors started in the beginnings of virtualization back 10, 12 years ago.
Exactly, right. And it was a challenge, of course, implementing this. And we had to support all the instructions, many possibilities.
All of the possible CPUs. And,
yes.
And back in the days of binary translation as being the primary way of doing virtualization, we couldn't get very large virtual machines. There were some challenges around scaling virtual machines with that.
Right. So there are some limitations using, of course, it might seem a little bit inefficient, but we had many optimizations in the HVX. We still use it. It's very usable, and we had to put many optimizations in it. We cache instructions that we already translate. We don't need to translate every instruction all the time. But when we go up with the CPUs, we're going from 8 to 16 CPUs, things start to get a little bit...
it gets much harder to coordinate as you're going through that.
Right. So there are some issues involving CPU synchronization, and we've seen that making the HVX hypervisor work for large number of CPUs could be a very challenging task. We are still working on it, but it is not very cost efficient. So what we basically moved to doing is in modern clouds, in some of the modern clouds, we already have support for hardware assist, which means that the cloud instances themselves run on CPUs that support running nested virtualization on top of them. For example, Intel VTX or AMD SVM. And by that, we can run instructions seamlessly directly on the CPU without needing to without the need to do translation. And
this is where the underlying CPU adds another layer of privilege beyond where the operating system usually sits, and the hypervisor sits in that higher layer of privilege.
Right, exactly. So once we had that, we can use simply KVM, okay, which is a very common hypervisor. You use it in other...
Used in many of the public clouds you're running on top of.
Exactly. So now we can run on these clouds, we run KVM on top of the cloud's hypervisor, which is a KVM sometimes.
And this is very much parallels what happened with running on top of physical CPUs. When those feature sets became available in the physical CPUs, we got huge leaps in the performance and the scalability of virtual machines. And now we're seeing the same thing going on for the HVX hypervisor sitting on top of another hypervisor. Still freaks me out that we're doing a hypervisor on top of a hypervisor, and in some use cases we run a hypervisor on top of that because you support ESXi on top of HVX on top of whatever the public cloud runs.
I agree, but we also support the bare metal instances, which are simply physical machines, and we run KVM directly on top of that. So this is only one layer of virtualization, but the difference in performance is not that big. It's only some small number of percents different.
So the big shift is from binary translation to hardware assisted.
Right. The difference between the physical machine and running on nested virtualization on top of other virtual machine is not that big because of the nested virtualization support in the CPU. So the number of layers becomes insignificant. And the technique, the virtualization technique, is much more important for at least for these workloads.
And it's that support for hardware assisted and bare metal that's driven Ravello to be able to support the larger numbers of CPUs per virtual machine, and presumably it has an impact on also the amount of memory.
Exactly.
That the VMs can.
It allowed us to easily use larger VMs without worrying about supporting many new features in our own hypervisor.
Because you simply pass them through from underneath.
Right. So it's much easier.
Excellent. And presumably this is the forward direction for all of the Ravello. The strongest forward direction for the development is towards those hardware-assisted, much less engineering effort to make things work.
I guess so. It's very dependent on the cloud providers. But as long as they will provide hardware assist, we can use the new technique, so it will be better.
And thank you for watching this vBrownBag Build Day video with Ravello. Keep watching the vBrownBag channel for more Build Day videos. I've always been intrigued by the interaction between the different CPU features and architectures and the actual delivery of performance into the applications and the impacts, and sort of the way that some things are huge changes and some things are relatively small changes, and the different ways that CPU is being delivered here are interesting as well. We're still running through the benchmarks, so Weathervane is still hard at work pushing these virtual machines and finding out how well they run. So what I thought we should do is have a look at a little bit more of what's going on in the Ravello UI, and I think there were a couple of things you wanted to look at in here as well.
Yeah. So there are some things that maybe we should talk about Blueprint to begin with. So Blueprint is basically a snapshot of the entire application, of the entire environment. It's like a VM snapshot where you take the state of the disks, but it's for all the VMs in the application and the state of the network and the rest of the metadata of the application itself. And blueprints are really cool because then you can instantiate an application out of a blueprint in a click or an API call.
So you can mass produce from that blueprint, the same as an actual blueprint for manufacturing.
Yeah, and then an entire application or entire workload becomes basically an object, a library item, right, which you can spin up immediately. And because network is fenced, you can then create multiple copies of your application. So again, test and dev is one example. You can create multiple copies of your production environment to run your multiple tests on top of it, a copy for each developer or a group of developer or automatic tests. Other use cases would be training, for example. If you have a class of 20 students and each one have multiple VMs in his application, you can just spin up 20.
As a trainer, doing it through this method would have been great, because the number of times that I would troubleshoot the lab build for a new course where I would have 8 sets of physical hardware, and if the deploy hadn't worked correctly for all of them, I'd be going in and fixing multiple of them, and it was on physical hardware, and we know how challenging that can be.
Yeah, exactly.
So the blueprints live in the library, don't they?
Yeah. So you can go to the library.
And there we go. There's my blueprints.
So if you are interested in the Weathervane,
there we go. If I select the Weathervane and
just click on the link itself, the name of the blueprint.
If I can drive my Mac.
Yeah. So it opens up a blueprint which looks just like your application, but not published. So you can see the VMs, same configuration as everything, the same network. It's basically the blueprint for your application. And now if you want to create another copy of Weathervane out of this blueprint, you just click on the button there and go through the same process as when we created a new application from scratch, only that this time the VMs would be there with their configuration.
Right, so when I created the file that I need to interact with. Little glitch there, and we're back. Nice and easy way to build out a bunch of VMs, and obviously I built out the 3 Weathervane apps that we're using to run our benchmark now from this, which was nice. How are we going on progress? So look, we've completed. So let's take a look what we've got. Let's start with binary translation, which is the oldest CPU type in this bright. Oh no, that hasn't finished yet. So maybe we'll have a look at hardware assist. So hardware assist has run this 1500 user auction benchmark, and The thing that I look at, and this is how responsive was my application. And so there's an average response time in here that shows as 0.013 seconds, so 13 milliseconds response time. That's considered to be acceptable for a website. And so I've got a spreadsheet. I'm just going to track in a spreadsheet here the performance of these. So my hardware assist with 1500 users was doing 13 milliseconds. And bare metal, so the hardware assist and bare metal were both ones that are running on the Oracle Cloud infrastructure.
Yeah.
Again, both of them running the same workload, but bare metal has been even better for latency. It's down at 7 milliseconds for these 1500 users. So we're seeing better application performance even though they're not saturated. And then how's my binary translation going? Still taking a little while. It's looks like it's has to work a little harder. There we go. That was 54 milliseconds for binary translation. So all three of them successfully ran 1500 user option site. That's a good thing. We've definitely got some performance going on. But it's immediately we can see that there seems to be better performance from the hardware assisted and bare metal. As you can see from the spreadsheet, I'm going to ramp it up. I'm going to double up the user count, and we'll see how that behaves. So we'll just get that started to run a 3,000 users in binary translation, 3,000 users in hardware. Get my spaces in the right places, and 3,000 users of BIM 1,300 would be too easy. So a fresh run of Weather Vane again with more concurrent users on the auctions, and that therefore means more workload going on. What else should we have a look at? Well, we were looking at the user interface, and I did also spend some time with Noam recording some looking at the user interface. So, Jeffrey, are you ready to put up the interview with Noam? Hey, welcome back to another vBrownBag Build Day video here at Ravello in Israel. And for this video, I'm joined by Noam. Can you introduce yourself to the folks?
Hi, I'm Noam. I'm the UI team leader, and basically work here for 2.5 years.
And you were saying 2.5 years makes you relatively new in here? Is it a team that's been together for quite a while?
I'm new regarding like the old ones, but there are a lot of people that newer. Like,
there's been a lot of people join, I presume, since the Oracle acquisition. The engineering has been kicked up quite a lot.
True.
But that's not what we were going to look at. We're going to have a look at the user interface, since that's what you're team lead for, and it's this wonderful web UI that we see and we spend a lot of time in, and that I really like because I've used other people's cloud interfaces, and it's really hard to coordinate and understand the relationships between objects in there, and they always just give you a tabular list. There's never anything very visual, so I like that. So what have we got here at the moment? So
right now you can see our app list. You can see that we have 2 draft apps, and we have like 3 application stopped application. What we're gonna do is create a new app. Thank you. Create a new app. We can call it our app. SAP. Our app. And we can just choose one of our blueprints, and let's create. And we reach our wonderful canvas. So you can see here we have 7 VMs, not running yet, not published yet. It's not on the cloud. And this view allows you to, like, it's visualizing the application. We can do whatever we want. We can add more. Let's look for a VM. We can just drop another VM, and that's very cool. And we can see all the VM settings and change them by, like, start from name and add disks. You can do just like add a disk, and you can just choose whatever you want. We will do save, and Let's close it. And it's saved.
So that ability to drag things around, in this case, the vApp was set up to visually represent the layers of the application. That the app was set up to show the layers from front end on the left through all of the middle and right hand as the back end tiers. And that's a really nice visual representation that's persisted through the life of this app.
It's true. It also, we can help you like visualize it better if you do grouping. So let's say these two VMs are in the same group. Let's say DB group, okay? Not really DB VMs, but let's go with that. And we, if we will say we have another group, like the service group, let's make it another color. So you can visualize it and it's like much prettier and much organizer. But it's not like the only view we have. If you have like tons of VMs and it will be hard to see here, you have also the VM list, same functionality exactly. Like you see here, the VM props are still available. And you just like go with here, search for your VM, and
so if I had 800 VMs and I was looking for a specific VM, search is rather important.
But you can also, okay, it's like you can also do it in the canvas. We have this search, but like it will be, and it will focus on your specific VM, but like 100 VMs will be hard to visualize and print. Beside that, you have also the network view. It's our new network view. You can, like, the concept is to see all the networks aspects from switch, subnet, routers, and it's like much details view that you cannot see in the canvas.
And you have two different ways of approaching the different pieces. You're in the left-hand side having that tree structure showing the individual objects, but you can equally on the right-hand side, you can choose objects and you can manipulate those from the right-hand side if you're doing much more bulk kind of simple actions.
You're talking about this side?
Yes.
Yeah, so indeed, like here it's the hierarchic tree and it's like much clear view, like you know which thing will be under each node.
It looks a lot more like configuring a physical network in that you have a hierarchy of ports and services running and those kinds of things. Whereas the right-hand side for me is not a networks guy, it's a server guy. The right-hand side where it's more visual works for me.
It's not just because you have here also a small canvas, but you can also see like you have the same data. Here you can see switch 1 and switch 2. Here you can see, and you can just dip in and it will obviously sync with the tree. This entire view wasn't that easy because it's like very complicated, model, let's call it model, very complicated model. And it took like, I think more than 1 year to design what will be the relation between each part of the model.
Types of objects in there. And that I know was one of the really big things in this year's release was around getting that new data model underneath the network and allowing much more complicated networking to be configured in here.
Yeah, and it's obviously wasn't that the UI, but in the UI view, we did a lot of researchers and we did a UX lab that we called our customers out of Ravello Oracle, and we asked them to do some tasks, and we started to I forgot a word, not investigate, but just like trying to understand. We recorded it and we just looked at the videos and tried to understand why the user do whatever it does.
Actually learning the
behavior.
The random or semi-random behavior of real users.
Yeah, and try to understand not random, why it's not random and what caused each click, like really clicked. If they had errors, we try to understand why they did it and how they solved it. And then try and optimize that flow for them, that they don't have to go so many places to resolve the issues. Yeah, we did a lot of changes in the UI because of this lab. It was really good thing that we did. And
so what else have we got in here on this this at. So we've also got a log of every activity that's been taken. So the next tab across is a
you have
a
log of like each application. So you can just go here, search. You have every action that has done in the app will be in the log. You can also get the log. Yeah, okay. So believe me, there is a log here.
There it is.
Yeah, and you can see the entire log of all the organization. And beside that, we have this nice library because we want you to reuse the things that you already done. So we have blueprints, and I guess you know what blueprints, right?
So blueprints, the predefined collection of virtual machines that will run some application.
Yeah, and with the data and all the network
and all of that layout in the canvas and all of those properties.
Yeah, so you can just save any app, ask for saving a blueprint. So
save as blueprint.
And voila, we will have it here. And from now, we can just create an app from this blueprint from here, or like we did as
you did in the application list previously.
Yeah, and beside blueprint, we have VMs and disks because we can save also like the VM image or any disk.
And I use the disk images to get ISOs up, as well as you can upload VMDK files as whole disks.
Yeah. Also, when you import, you know that we have, like, we can import VMs from ES6 by the import tool that we are not talking about right now. But once you will upload using the import tool, your VMs or disk will arrive here to the library, and you can use it for any app. Okay. Before that, we added disk from just a new disk, but but we can do it also from here, from the library based on image, and you can see all your disks.
Excellent.
And beside that, like, you can publish and choose which region do you want to publish it. Let's say I don't see Australia or something. Let's say Sydney, and published. And now you can see, like, the status will changes, progress, you will wait. And once it will be green, you can work almost. Like, it's different than the VM is up, but the app.
So the hardware has been initialized, the operating started, but the application
so
not yet.
You need to wait a bit. And once you have one running, you can also connect during the console. I don't know if you saw it. We can wait, but it probably take a bit. So we can
and that console is nice that it also shows you the boot time of the VM. It's not reliant on the operating system, it's the virtual hardware console, and so you can see the virtual machine post and all of the OS startup.
Beside that, you have tons of options. We have, like, the normal option, start, stop, restart, and we have also ephemeral access. If you want to grant give someone your app so he can, I don't know, connect just by console, but you don't want him to be a Ravello user, so you can grant an ephemeral access that will expire whenever you will tell him.
Revoke the
and with a specific permissions, and you can also do it.
So that will be useful for students who are attending training that was delivered through here.
Exactly. We do it for the training portal. It's another service that we have. So it's a cool service, and the students doesn't work with Ravello, they work with
the clients.
The client,
Excellent. Well, thank you, Nan. It's been interesting. I really like this user interface. I think it's one of the nicest cloud management interfaces that I've used. So thank you very much.
Thank you.
And thank you for joining us. Keep watching for more of the vBrownBag Build Day videos. So Noam and I looked at quite a lot of the parts of the user interface, but there are a couple of things we didn't have a look at that you mentioned that could be interesting. What should we have a look at first?
Yeah, so there are a bunch of other features that are very useful for multiple use cases and enterprise usage. We can start by looking at availability groups, for example.
So if I pop back in here and let's look at this newly created WeatherVane application that I've deployed that's not currently running WeatherVane. What are availability groups and where are they in here?
So in a production environment, you would like to make sure that your are available, and you would like to place them in an on-premise environment on different hardware. In the cloud, it's hard to...
So it's a late night here. So it's Thursday, which is the end of the working week here in Israel, and it's currently 9 o'clock at night, and we suspect there's a bit of maintenance going on in the building, and you will have heard quite a bit of audio interference going on, and my guess is there's some electrical equipment here which is just bursting out in RF. So please forgive the noise. It is because we're at such a late time here. It's one of the interesting things about being in Israel is that the working week does not begin on Monday here, it begins on Sunday.
It begins on Sundays and it ends on Thursday, and this is now the end of the week for us, but the US is still
still
full
2
working days. Yeah. And when there need to be some maintenance in the building, so people are asking, okay, when should we come and do the maintenance? So won't bother anyone. Thursday evening.
After the working week is over, yes. And of course now outside us, there's almost nobody here in the Oracle Ravello offices at this time on a Thursday evening because they're home with their families or out with their friends, apart from the maintenance workers who are helping our audio to be challenging. We're going to have a look at the function in here for availability groups.
Yeah, so basically availability group is just a feature that would let you define a group of VMs and say these VMs need to run on different hardware. And in the cloud world, it means 2 different availability zones, availability domain, availability groups. The terminology is different in different clouds, but
this
basically
is separating it out so that they're across 2 different failure domains.
Yeah, exactly.
Infrastructure.
2 different buildings, basically. And the way to set it up is pretty simple. There are 2 availability groups currently that we provide in Ravello, and you can just say, you know, this VM is part of the first availability group, and the second one is part of the second availability group. It's been marked on the VM itself in the configuration. I haven't done it for a while, so let's try and figure out where exactly it is.
And of course, this application is currently running, so I can't change.
Yeah.
Well, why don't I just deploy us a new application that we can make a change on?
Yeah. You cannot change it on a running application because the VMs are already deployed. So you can just say, okay, deploy it somewhere else.
And being all cloud and all virtual, I've already created.
Exactly.
Here's my new vApp, new application, and now I can change. So one's in availability group 1. And this other virtual machine can be an availability group 2.
Yeah.
Now, this presumably has some impact on cost for me, because now instead of having the possibility of running all these VMs inside one instance of HVX, I've now got to have 2 instances of HVX, and I imagine that's going to have a cost impact.
It has impact on... It may have impact on us. As far as you're concerned, the pricing is based on the
workload that I'm running.
Yeah. Right. So it has nothing to do with availability group for you. I mean, we would need to now figure out how to fit it in different hardware pieces, different infrastructure underneath the application, but we deal with it. So it doesn't change your pricing.
So again, like a cloud provider, you for a start, the bills for all of these VMs come from Oracle Ravello rather than from the individual cloud providers.
Yeah,
but you handle all of the underneath, making sense of that.
Yeah. That was also very important for us from the beginning to kind of abstract the underlying clouds, because as far as you're concerned, this is a workload that came from the on-premise. You should not care in which region your workload is running. So it is important in terms of where in the globe it's going to run. And nowadays, when we are part of Oracle and we support the Oracle regions, then there's some privilege to the Oracle regions. But other than that, the goal is to make it completely abstract. And also, in order to do it, we wanted to abstract the billing part. So you work with Ravello, you pay to Ravello, and we deal with the cloud infrastructure. You don't need to create multiple accounts and tie them into your Ravello environment. So we started this way, and obviously billing and cloud is a big issue. You know, we noticed it at the beginning ourselves. We started small, the R&D, and then we came up with this babushka concept, and we start using Ravello for R&D.
Multiple of your workloads then.
Yeah, and I remember the very first days before we really had a service. It was not, I mean, it was just development stages. We were in stealth mode, and we had 2 servers in the office, and you keep on hearing people shouting, "Who just rebooted my Tomcat? Who started the Tomcat?" Blah, blah, blah. And at that point, we said, "Okay, we have to eat our own dog food," and we're now using only Ravello to develop Ravello. There is no hardware in the office. There is only DHCP and the relevant security pieces. There is no data center that we manage. So it's all on Ravello. And in the beginning, obviously, things went wild. The account went wild, and then we understood that we need to put some controls on top of it. So this is why we have this like stop timer on the application.
So that came about because you saw your own developers' behavior rather than that's interesting how these things come about.
Yeah, of course. Our own developer behavior, which is obviously you use it, but on the other end, it's like, you as a developer, you don't pay the bill, so you need something to help you take
help you to behave nicely.
Yeah. So there's this feature, and there are also other nice features on the billing administration page, which we can actually look at.
Whereabouts do I find that?
We have time for it. So it's at the admin
and billing and budget.
Yeah. So this is the basic view. You can see the monthly. It's always monthly. You can select different months, but this is for December. You can see the overall cost and how it is being broken down by components, and then you can see the list of applications running, stopped, and deleted through the month. So you can see how much of your budget was consumed by each application and each user. So that's the first thing. You can also extract it into a CSV file and run your analysis on top of it.
And feed that back into potentially a showback system internally for your teams.
Yeah.
First of all, we should be showing shekels as opposed to dollars here, because that'll really blow people's minds how many shekels that is. But we do have Daryl Lundy on here, who's first time for Build Day Live. And he's asking, does each dev have their own Ravello login or HVX?
So each developer has his own user, right? His own just username, password. HVX is completely abstracted from the users. I mean, as far as the user concerned, he can run spin-up application and develop blueprints and VMs. And the developer itself doesn't need to care about HVX. We care about it. We take care about it. You just get your user, you log in, and you can start do your stuff. You can now put some restrictions on users, right? You can define different permissions and permission groups per user. So you can have your QA team and your R&D team, and you can say, okay, QA team has access to this list of resources, and R&D has access to a different list of resources in terms of blueprints and VMs. So
can you also do quotering?
Sorry?
So can you do quotering and say this group of users are allowed to spend X dollars per month? Is that in the product?
So you can do something really. There is no control. You cannot stop them from using it, but you can set up alerts and you can see exactly how much dollars each developer consumed or each group consumed, and if we go back to the billing and budget page, then you can create cost buckets. Cost buckets are basically like cost centers, basically buckets where you want to put your billing at. So this is.
So maybe I have one for Siebel and one. Oh, hang on! I don't want a bucket inside a bucket there at that level.
You can create an hierarchy.
I can, but yeah, I might have a separate bucket for my weather vane testing.
Yeah. So now there are two buckets, and you would like to associate your applications with different buckets. So you can do it on the application at the application level, right? You can go to application, and in the settings tab, you can attach your application into a cost bucket. But what you would usually like to do is you would like to differentiate it by users, right? So you would like to say Alistair is using all the workloads are on the first bucket, which I don't see its name.
I've got a bucket called weather vane here, which now contains my 3 weather vane apps that I'm running.
Exactly, and Jeffrey can only access the other, has permission to spin up application at the other budget, and then it's completely seamless, right? Because when you'll come and publish an application, you get to choose on which cost bucket to put the application, but you'll have only the weather vane, and Jeffrey would only have the other one. If you have access to multiple buckets, then you can just decide on which bucket you want to put your application at. And on a bucket, you can then set alerts based on your budget. So you can say my QA team is limited to a $500 budget a month, and I want to get alert when I reach 70% of their budget. We wanted to avoid putting real control features on top of it, because that's really tricky in this kind of environment, right? It's really easy to exceed the limit, because if your budget is too small and we're working in an hourly resolution, it might be the case that you stop the application when you reach the budget, but at the end you would exceed it significantly if you're running a lot of applications.
But yeah, the alerting and visibility, I think, is useful in there as letting people know that they've used their allocation, but not stopping them from being productive at that point.
And you can send the alert to their manager, which would take responsibility and say, okay, guys, you're reaching 70% and it's just the middle of the month. That's,
what are we doing different? Because, Nice.
By the way, the Oracle Cloud infrastructure, the systems that sits on top of Ravello, has some similar functionality that also has control for your entire Oracle budget, not just the Ravello one.
Is there some sort of way to kind of, if things go overboard too fast, is there a way that it can be stopped or
forced to
would
be
everything
stopped?
just stop, or would they continue to go?
With this functionality inside Ravello, no, you just get an alert. With the Oracle, the OCI functionality sit on top of it, yes, you can set up, I think it's called hard quota, so you reach a quota, and it would, I think that then it would prevent you from spinning up other applications. That depends on the configuration.
Now let's just see if all of our weather vane is still running here in the last in this 3000 user load is still running. So we get some really good visibility in the billing there. We get the ability to have multiple users accessing the same account and devolve control of parts of it. So that's nice sort of functionality in there. We've looked at the availability groups. We do, Jeffrey, have you got the naming of Ravello video ready for us? Because I think that fills in a nice couple of minutes. It's the one where Benny discussed how Ravello Systems got its name. And once that one has run, we should have this run of weather vane complete and all the results available to us. So Benny, one thing that we've wondered about. Ravello is a town in Italy. How does an Israeli-founded company end up being named after a town in Italy?
Okay, that's a great question. So first of all, if you look at the names of the company we had in the past, they all have nothing to do with what the company is actually doing. And the reason is, as a startup, you tend to change your view and you tend to change direction.
You guys pivot. I mean, when
exactly.
things aren't working,
we call it pivot. Yes. And we have done quite pivots in our life. Ravello was basically, from the get-go, we were following the idea. It was not the case in other companies. So when we look at the names, you can see that there is some pattern here. The first two companies, it was one company that was split into two, were named Pentacom and P-Cube. They started with a P. The next company, Kumonet,
with a Q.
Q. So obviously the next one should start with an R. Now, we named the previous one Kumonet after the Qumran caves. And the problem was it's misspelled because it's taken from the Israeli spelling, and it's after the Qumran caves, as I said. So we knew, and no American can pronounce the name.
No, so New Zealanders are relatively good with this. We have a sweet potato called kumara.
Okay.
So it was, to me, it was a kumaranet.
Okay. So it was actually after the Qumran caves, you know, where the Dead Sea Scrolls were found.
Yeah.
And it's a good discussion opener because many people know the religious history, but also the technology of deciphering the Dead Sea Scrolls, putting them together and understanding the history. So we said, this is a good idea, but let's not do it in an Hebrew, or let's take Italian. Everybody likes Italian. And we'll take a place where it's really nice looking. I don't know if you have been to Ravello.
If I type Ravello.com rather than Ravello Systems, I was taken to some beautiful seaside pictures.
Exactly. So this is one of the nicest places on, at least in Europe. It's in the Amalfi Peninsula, really nice place. So it doesn't talk about what it is that we are doing. It's a very nice place, very nice name, and I recommend everybody to go there.
And it started with an R.
Exactly.
Well, there you have it, alphabetical names for startups from Israel. So you can see why we want to go to the village of Ravello as part of our touristing for this, and it's a bit of a shame that we couldn't get there, but sometime we'll do this in Italy, and hopefully you'll join us, because I believe the food is great.
Yeah, it's an amazing place. It's beautiful. Food is great. We should follow-up video for this one in Amalfi.
Excellent. Well, actually, just as we started the video with Benny, the final of the 3,000 user Weathervane benchmark runs completed. And so here we can see that with the binary translation, the average response time became somewhat of a problem at 8,400 milliseconds, and the only 70% of the transactions succeeded. So clearly we have saturated the binary translation at 8,395, so 8395, and my conditional formatting says that's not good, it's gone red. On the other hand, the hardware assist, it's still down at 37 milliseconds and 99.97% success, so that's still good. That was 37 milliseconds. So it's become a little more loaded, but it's still coping just fine. And bare metal now has climbed to 10 milliseconds and 100% success. So bare metal is still giving us the best performance, and we can see a shift in capability that if we needed to accommodate this number of users on this configuration, binary translation isn't going to cut it for us.
Yeah. Yeah.
So yeah, I'll kick off the 6,000 user run, and you had some commentary on that one?
Yeah, sure. I think barely nothing in life scales in a linear way, and definitely performance in computation environment. So we can see that at a certain point things just breaks.
And Kunal, who helped me with all of this setting up, was saying what he had seen with Weathervane is that when it starts to degrade, it very quickly hits a cliff and performance absolutely tanks. And that, to me, reflects a lot of the tier 1 applications that we see out in production, that there's a knee where the performance starts to degrade and then it falls off a cliff, and you get a lot of help desk calls and people who are very unhappy with performance at that point.
Yeah.
All right, well, we have a little while this run of the benchmark goes through. I think it's probably a good time to return to one of the videos with Amit about the software-defined networking that was in here. In our first discussion with Benny, he talked about how the layer 2 within the cloud is not possible, and that was really the driver for the SDN, and Amit has some more information for us on that. Welcome back to another vBrownBag build day here at Ravello in Israel. I'm joined by Amit again, and quick introduction, Amit, for the people who haven't seen you on the other videos.
So my name is Amit. I'm working in the virtualization group here in Ravello's R&D, and my team is responsible for the Ravello's software-defined network, the SDN, and virtual storage.
So we wanted to look at the SDN component, and particularly unpack why it is that the SDN is such a central part of the Ravello platform, and what were the challenges and what were the differences in cloud networking that you're trying to address with the SDN?
Right, so one of the gaps we had to bridge over when doing lift and shift of scenarios, I mean, when we want to transfer workloads to the cloud, is that we didn't want the users to change too much their network topology. And currently, the public clouds are supporting only L3 communication, which means only IP-based communication. That means they do not support VLANs or ARP request or replies or any non-IP communications at all. And this is, I think, from the customers we've seen so far, this is quite common for organizations that already had their virtualization environment to have an entire network topology that is non-IP based or that has specific rules or configuration that you cannot just reconfigure on the cloud. Because
so it's things like scenarios where on the cloud you have to use specific ranges of IP addresses. Right. That may not match up to your on-premises IP ranges, and the way those IP addresses are assigned is very different to on-premises.
Right. You would have to change all your static IPs that are defined on the VMs just to match them to the, if we're talking about Amazon, so the AWS VPC, you have to define one subnet, and you need to change all the IPs in your application to match the subnet or create multiple subnets and connect them in some complicated way.
There's no way that static IP addresses on on-premises have ever been coded into the applications we're running. That just, actually it happens a lot.
Right, and so that's the first problem, but we also see a lot of requirements such as VLAN topology, some complicated switch mesh of topology, companies that do like network, all sort of network appliances or applications that are network intensive. So
there might be something that's in a mail scanning application that needs access to multiple networks, or there might be something in access control management software that's mandated by legislation that you must use this, that makes some assumptions about how networking works.
Right, or traffic generation. There are many applications that
absolutely all of our content available to freely consume at your leisure and download onto your favorite device to watch as you commute. The weather vane still running. It's going to be a little while yet to run up, and I'm running a little dry on things to say at this point.
So we could talk a little bit about UI versus API, and so it's like in every cloud-based system. I mean, APIs has to be the major way to use the system, and this is how we design Ravello to from day one. So everything that you can do with the UI, you can do with API. Actually, our UI is built on top of our public API. There's no hidden
There's no private APIs
No
that
private
are
APIs
driven by the
there.
UI.
Yeah, everything is just public APIs. It's a RESTful API, quite simple. You can do really cool things about it, and we have a video by Matan showing how you can use the API. And actually, many of our bigger customers are using the APIs. It's just like building their systems using our API and integrating them into their workflows.
And we saw at the Ravello Blogger Day 6 months ago that there are customers who use their own interface, their own web interface for their customers that then drives the Ravello API to deliver that service back to the customer, which is a pretty cool functionality.
Yeah, it's cool, and it's important if you want to grow as a company, because we love our UI and it's really great. And I can talk a lot about the canvas there and how important it was for us as a startup to succeed. Really, it has huge psychological impact even on customers. It somehow magically simplify the complexity of an application, even though it doesn't add any extra information. I mean, you could just usually you see a list of VMs with the details. And
a software developer wants the table of information, but I, as an operations engineer, want something more tangible or visible.
Yeah, and eventually even software engineers end up liking this. And again, it doesn't add any extra information. It just kind of simplifies the complexity, and it makes you feel like you understand what's going on there. But there's tons of functionality you can build on top of a UI, and this functionality differs from customer to customer. And eventually, when you're a heavy user of a system, mainly a cloud system, you end up building your own portal, because you have slightly different flows, and your permission mechanism is slightly different, and you have different types of layers of users, customers, internals, and so on. And usually you'd like to bake it into your other backend systems. So most of our big customers are actually they're starting with our UI, and we have some other small capabilities that we added to help people bootstrap, like a training portal. But eventually they're just building their system on top of our APIs.
Yeah, right. And that's what we'll have in this next video with Matan. Do watch a little. If you're just listening to the stream while you're carrying on with your work, Matan has cerebral palsy, which affects his speech. And so there are subtitles on this section, because although we've spent some time with Matan, those of you who are watching have not. And so please do pay some attention to the subtitles in this. So Jeff, if you'd like to put on Matan's
go to
video.
Full page.
Hey, welcome to another vBrownBag video. We're here doing the build day at Ravello Systems. I'm joined this time by Matan Weisner, who is going to show us the API integrations that we have with the Ravello platform.
Yes. In Ravello, we have a goal for our system. You can do by the UI, you can do by the API. The UI use the API for the aggregation via the server. For example, let's assume we have this developer and we want to create an application from developer and publish it. And I now create application name app from UI markup Matan. Great.
And this is the way I normally work with Ravello, because I'm usually just creating one or two applications, and using the user interface is the convenient, easy way for me.
Let's to publish the app. We can just from where within. Let's do the US software to run. Publish. But our aim is publishing. Let's do this from the API.
So this is using Postman in a web browser to directly call the API.
Yes. I use direct repository to send the request to the Ravello server. I sent that I want post to application to create a new application that its name is Matan app from API based on the same blueprint. And I got OK, created, and this is the reason that describe the created app.
And that JSON's got all the properties that we see in the GUI, but all delivered down in the response body to that API call.
Yes.
Excellent.
This is the exact parameter that you can see in the GUI. Let's our application Matan app from API. Let's publish the new application. Let's copy this ID. We are post with this ID to publish to US software one. Then
this is where it takes a little while to actually instantiate the machines and get us back the body. But we're going to, again, get a nice rich body back as JSON information about the VMs that have been created.
Yes, we get back the properties of them. And we can see that our VMs is starting. Let's do it from the SDK. I was a terminal that I am forwarded it our SDK.
So you've got this is a Python SDK that's calling the same API. Is much more easy to use repeatedly than Postman directly calling the API.
Of course.
And you've already authenticated, and the same as you have with Postman, you've done authentication beforehand. It's not open and it's publicly accessible, but it's secured.
Let's create a simple JSON with name and base blueprint ID. Let's use the SDK client to publish our application.
And we get an object back this time rather than a JSON.
Yes. This is the object that describe the new app, and we can publish our new app, client publish application.
On that same object. Nice.
Yes.
So that was what, 3 lines of code? We had to first, so we started the 3 lines of code with the blueprint ID, which you might have statically, or you might go in another line of code to find the blueprint ID. Nice and easy.
Okay.
And we've only got 4 VMs in here, but that blueprint could have had hundreds.
Yeah.
Nice. And should we take a look at the list of applications and just show that SDK, that one that you've just created with the Python SDK, looks exactly the same as the one from the API? And now we have that Python SDK
from
one at the
UI, the app from API, and the app by SDK.
And we have access through the SDK, so I didn't notice where you specified the region to deploy, but that presumably there's a property in there to have a region when you deploy that app.
We can specify the reason if there is a parameter name of optimization level. If we would performance optimized, we need to specify preferred reason, and if we say to perform to cost optimization, Ravello choose by itself.
It'll choose the cheapest region to run this particular workload.
Yeah.
So, thank you, Matan. We have seen that the Ravello interface is an API first, and that the GUI is just a client of the API, and that you can call the API directly, or you can use a Python SDK to interact with the API. This makes it very easy to integrate with your own Jenkins environment or some lab deployment methodology or whatever automation you want. Really nice functionality, and that seems extremely easy to work with. Thank you, Matan. So the ability to use the API and the language bindings that are the SDKs that are provided is really useful to scale your use of Ravello. That the clicking in the UI is good for doing 1 or 2, half a dozen application deployments, but to get to high velocity, large volumes using the API is a really central part.
Yeah. Definitely, when you look at, for example, continuous integration and automation, test automation, this is really strong.
And this is again where the full copy of production that's stood up just for the duration of the test and is torn down and thrown away as soon as the test is complete. That integration is really cool. We are still waiting for the weather vane run. It's still running through 6,000 users worth of auctions, and I think one area that we haven't really talked about is storage, because of course with all of these machines they've got to be stored somewhere. We've talked a little bit about how it works, but there is a crucial part of storage underneath all of this. Yeah,
storage. There are actually all kind of interesting challenges with storage and cloud, and the fact that you want to have. So we said that you can spin up your application multiple times. You start with a blueprint and you spin it up a couple of times in one region, and then you need to spin it up in a different region. It could be Australia, right? So it might be that you developed your application in Virginia, in the US, and now you need to spin up a couple of copies in Australia and then in Sao Paulo. And there's a lot of storage that need to be spread and being sent all over the place, and it's obviously very challenging. And not just that when you start your application, you need to get your storage into a different remote location. It's also when you save a snapshot, it needs to get back. When you can save a blueprint and then spin up another copy from the blueprint somewhere else. There's a lot of storage moving here and there. I mean, to talk about the implementation, but one thing that is important to remember also when you use the system is that when you put up the application, we do not fetch all the storage right into the instance, because that will take a lot of time, right? We basically start by mounting the VMs are the OS is mounting a disk, but the disk is actually on a cloud file system that is distributed. And when you start fetching the blocks, when you start the boot, and the OS needs a bit of disk to start the booting process, it would start fetching the data from wherever the data is, might be remotely or local. And when the VM is trying to access another bit of the disk, it would fetch the next bit of the. And it has also effects on on boot time, for example, and also on performance. So we run the benchmarks here. We know that the data the applications are running and disks are there. If we now spin up the same application in Sydney and start the benchmark there, the first run would obviously be very, very slow, because we need to fetch the data.
We need to warm up the local copy of data.
We need to warm up the local copy. And it's not just that, it's if you take a VM, if you run the benchmark for the first time, and then you try to access another bit of the disk that you haven't touched yet, it would go and fetch this bit as well. There is at the background, there is a process that's trying to prefetch and bring the rest of the data, but there's a process there.
But there's also a cost involved in moving between regions for cloud providers, and so you want to optimize that and not retrieve data that's never going to be accessed. So there's a balance to be played in there.
Yeah, there's a balance, and this is why we also have caching systems and so on that Amit described in his talk.
So let's have another video from Amit talking about the software-defined storage components of the Ravello platform. Hey, welcome back to another video of the vBrownBag build day here at Ravello. We're going to talk a little bit about a user story and what it really means to the underlying infrastructure, and I'm joined again by Amit to talk about, this was we were talking just before about this large global training organization that is all over the place in terms of where they deliver, that week by week they could be delivering training everywhere using the Ravello platform. Just what kind of things go on with that?
Right. So far, these training organizations had to actually move racks with servers to some parts of the world, to Australia and to Singapore and to Europe, just to start their training course in that specific area.
So that would be a sort of 2-week lead time as a minimum if you're shipping racks full of equipment, from basically a 2-week gap between courses for each piece of equipment. That would cost a lot too.
Of course, not to talk about the manpower that needs to accompany that and so on.
And having been a trainer myself, the lack of power resources in the typical training center could be quite restricting.
Exactly, and the training systems could be quite complicated. Some of them requires thousands of VMs just to get going, right? So in Ravello, we try to fix this problem by allowing easy cloning of the VMs to different regions and different cloud providers that supports different regions. So this is one challenge we had to overcome while thinking about our storage architecture, or our Ravello storage layer. And another thing is, once the training starts, the trainee or the trainer wants the VMs to start boot immediately, right? They don't care that they were originally uploaded to the US or something like that, and somewhere like that, and they will now need to copy terabytes of data to the desired location.
Particularly if they've got thousands of virtual machines, it's going to be tens of terabytes.
Of course.
And the students need a good, fast user interface, so they want those VMs to be nice and close to where the students are.
Right, and they don't want to come 3 days in advance to download all the data, right? So what we did in Ravello, we built some sort of an abstraction layer with our own file system. We called it CloudFS, which actually helps us to start the VMs immediately and fetch data ongoing from remote regions. And we have all sorts of optimizations to do it in an efficient way. So the user will not have to wait for the VMs to actually start the booting.
So the VM starts up before it's been copied to wherever it's executing, just parts of it
need
to be pulled.
Right. We have many optimizations. One of such is our prefetch process, which runs on the hypervisor and downloads data in the background to help accelerating the future use.
Launch, yeah.
Yeah, so this is just one optimization out of many. And we also cache the data and so on to avoid the cost of bringing the same blocks again and again from remote locations. And by that we solve both of the challenges together. We can boot immediately and we can run the VM anywhere, on any cloud and on any region. We store the data in the cloud's object storage. Okay, this is a concept that means that it's just a big bucket of bytes. You can put there anything you want, and this is accessible globally and efficiently, hopefully. So we put the data there, and then we fetch only the parts we need during the runtime, and it helps us to be available globally.
So you must be breaking the large virtual machine up into lots and lots of little objects in order to be able to manage that tearing, and you're sharding the objects out so that they're distributed in different places and you can cache them more easily as smaller units.
Right, of course. And what we also do is when the user finally decide to save the snapshot of the VM, we upload to the cloud only the delta, only the diff from the previous write. So we don't need to upload terabytes of data to the same location where the VM is. And the VM, it creates such like a chain of files that are connected to each other. Each file contains more data and there are more recent changes. And when the VM starts, it reads only the data it needs from all the pieces of the files.
Right. So it's quite a lot of smart in that structure. And was talking also before that object storage is not just in one place. It's not just a single object store somewhere. It's actually also spread.
Right. It has many endpoints in every region, most of the public clouds. And what we do is we store the base image wherever the user wants to upload it at the beginning, and then we just upload the new write, the diff we call it, to the same location where the VM was started. So if this training organization wants to do training in Australia and they set it up the VMs with some configurations and they installed some components on it, so when they save the VMs, the upload would be very quick. And when the VM would start again, most of the relevant data would be accessible.
Already be locally.
We also have many optimizations that copy data in the background from one region to another to avoid the cost of going to very remote regions.
Right. So all of this is really sophisticated underneath. It's what I like to refer to as advanced simplicity, where there's incredibly complex things going on underneath so that the consumer doesn't have to care about it. They just provision a virtual machine and say, I want to start it up in that region, please.
Right. Since we need to, we had to do optimizations to balance between latency and throughput and do it in averagely for all the clouds, because we want to support every region and every cloud. So we had to choose strategies that would fit most of the clouds in an average way. So the data would be fetched in the most efficient way. So we had to do some research to understand what's the optimal block size to fetch from the cloud in each call, and many other small details.
Definitely sounds like there's a huge amount of complexity underneath the storage system here, and quite a very sophisticated environment. Well, thank you again, Amit, for teaching us a little bit about the things we don't actually need to know about underneath the Ravello platform. Keep watching for more of the videos of the vBrownBag build day here with Ravello. We did spend quite a large chunk of Monday morning with Amit, but there was some really good material in those videos. There's one more video of him that I don't think we're going to play today, but that will show up on YouTube fairly shortly. And while that video was playing, we got to the end of the Wordvane runs, and surprise, surprise, binary translation that couldn't cope with 3,000 users coped even less well with 6,000 users. Its response time now was up to 17 seconds. So I'll pop that into my spreadsheet and be unsurprised. What was it? 17,164. Unsurprised to see that comes up as being a big bucket of fail. Hardware assist also struggled with 6,000 concurrent users, and so again we can see that it's not had as hard a time as the binary translation. Well, we're definitely suffering from the Thursday evening here with the internet connection coming and going as well. I think maybe there's a welding torch being used which is causing our interference, which is then taking down the internet. There was something weird's going on.
Welders use the internet. It's weird.
Yeah. It's the IoT welder. So we were talking about the complications of benchmarking, that really we were just doing a comparison here rather than a scientific benchmark of capabilities. But we do definitely see that differentiation of service.
Yeah, yeah. And again, it's important to remember that performance by itself is not, I mean, you need to think about cost performance, right? So that's another...
Yeah, and that there's a huge number of use cases where binary translation is going to be absolutely ideal because it's not about performance so much as getting functionality.
Yeah.
So that really does bring us to the end of the things we wanted to show in this build day. The significant things were that we took an on-premises enterprise application, in the case of Siebel Call Center, and we migrated it up into the cloud, and it operated exactly the same, unmodified virtual machines. Change management is going to be interesting on that one. The other thing I possibly didn't highlight was when we uploaded that file system virtual machine, we started with a running virtual machine on my ESX server. It didn't have to all be shut down in order to do the upload. In a production deployment, you're probably going to want to do something about synchronizing the data tier and making sure you don't lose transactions. But we were able to bring the thing up, and if you were doing that as a pull of a production application to do test dev, you don't have to shut down the production application on your vSphere cluster in order to get it onto Ravello, which is all pretty cool.
Yeah.
And then we looked at the different performance of the different CPU virtualization types, and just got an illustration of doubling of capacity for this particular workload as we move between the three different types of virtualization. So it's all pretty cool. I've been a fan of this technology for a long time. I think it's a really cool product and a really cool way of working with a cloud solution. And I was delighted to come here and spend some time in Israel and to show this to some more people. So if people who are watching this video are looking for more information, what sort of places can they find more information about the Ravello solution?
So there's a lot of information on the Ravello page on the Oracle website. There are plenty of videos as well, which I think you can also find on YouTube. There are a lot of blogs that we've created earlier, the days of Ravello, and they're now also on the Oracle blog infrastructure. And there's also a lot of blogs and materials that you guys created, the vExperts community. You guys were very supported through the years.
We appreciate it, particularly for me. Shruti Bhatt was, I think, VP of marketing in the Ravello Systems days. I know she's gone on to have a similar role across the whole new Oracle Cloud now. And Shruti, missing you. Sorry, haven't seen you in a while. But she made some really smart marketing choices and about engaging the vExpert community, and I think that has paid off very nicely for her. But also there's the evaluation. There's it's a free trial. It's actually a $300 promo on the Oracle Cloud infrastructure. The promo is for all Oracle services, so
guys should try all the suite of services, but Ravello is part of it. Yeah, you can sign up for the promo. You need to put your credit card, but the first I think 30 days, I'm not sure, but $300 are free, and you can opt in and out whether you want to continue using it or stop at the end of the promo. But it would allow users to actually test and see how the system is working.
Great, and that hands-on experience is really the proof for those of us in the engineering space.
And it's usually quite a lot in order to really test and understand the system. We designed it from day one. We had this free trial, 2 weeks free trial in Ravello, and we really worked hard to build the system such that users can accomplish at least an initial POC and get really confident with the system
inside that free time.
Quick. Yeah.
Nicely. So there've been a lot of people who have been involved. Thank you, Gal Moev, for being here with me and helping us to show and explaining some of the things on the insides of it. We've had some really good logistic assistance this week. So we've had Amir on the video, but Amir Tito helped us with the logistics of getting the networking all connected, and we've had our friend right outside the door, Juani, who has helped us to make sure that we got the right spellings of the Israeli names, because they're interesting spellings along. We had Emet Ebner and Omri and Natan and Noam and Einar and of course Benny, all presenting for us, and it was great to meet them, and thank you as a team for coming in and supporting us with that. Thanks also to the Tech Reckoning team, John and Kat, who helped us set this all up and are very active in helping startups and tech organizations engage with bloggers and influencers. Now, who else? Oh, and Kunal I've mentioned, but also Simon and an advocate for us also within Oracle Ravello of Naveen. This came about because he and I had breakfast after the Ravello Blogger Day. So lots of people go into making this, and of course, right behind the switching gear and in a few of the video, my partner in crime, Jeff, making us all look good.
Thank you very much. And of course, as Roni said, what word did we learn? Not that other word, but we learned to say thank you.
We learned to say toda.
So we say toda. So thank you, toda, and shalom. And I know you guys are going to have your holiday week next week, which is not really a holiday for you guys.
It's not a day off from work, but it's a holiday.
Yeah.
It's a holiday in your mind of reflection.
Yeah, it's a Hanukkah. It's equivalent to Christmas. It's also the same time. It's also about the light. But yeah, kids get the day off. We get to eat a lot of
celebratory food.
Yeah,
there's
really fat.
A lot of great food here. So I wish we could be here next week, but you know, we'll be flying back, unfortunately.
So all these videos will be on YouTube as our travel permits, and hopefully very shortly. So keep a watch out for those. And of course, happy holidays to everybody, and we will see you for vBrownBag Tech Talks and vBrownBag Build Days throughout 2018. So
yeah.
thank you,
Thank you guys for the opportunity. It was fun.